involves the interfacing between this federated learning and the quantum classical environment is shown here. So as we already discussed, federated learning, there are data will be running on the local clients, and there will be like sharing the data to the server. So again, there are like research questions here. So if at all I'm running, for example, instance, I'm taking like 10 clients running in my federated learning environment. If suppose two clients are getting slow, means not performing comparatively with the other 8 clients, then how come the model will be converged at a deterministic point of time? So that is again a question. So there are, as you all already know, there are like different environment, distributed environment there. Like one is synchronous and asynchronous environment. In the asynchronous environment, maybe the other 8 clients can go for the next round without waiting for the results of the other 2 clients, and probably it need to converge at one point of time, getting the model updates on the slower, comparatively slower, the other 2 clients also. So again, this is a open research challenge which you can explore more. So this is what is called as fault tolerance in federated learning environment, and this fault tolerance need to be like focused more on providing the same level of accuracy even in the absence of model updates from the other clients. So this is all about open challenges in federated learning. Then you have like hybrid quantum classical learning environment where a classical module will be running on a parameterized quantum circuits. So this will give you like gradients and updates as such in your federated learning environment. And this integration needs to have a concentration on as I've already told you, orchestration means like how many rounds you need to perform, how to coordinate all the clients in the subsequent rounds. Should I wait for the other client to join with me to proceed to the next round, or should I ignore the model update from the client which is showing the model convergence after a delay? So these are all the open research questions you can like explore on this HQCFL, right? So this is one aspect, kind of like distributed environments research questions. So when you come back to security and privacy of the model, so this is again a question mark. Why? Because since it is a federated environment, every client will be running on a different machine, which is totally distributed in a network. So in that case, how come you believe one client for its model update? So this is again a question, right? So there are possibility for that particular client to be a Byzantine node, means malicious node. So it can inject a fault model, or it can inject a corrupted model update to the actual convergence model, right? So again, that exists a question between how come you trust that distributed client to give you the exact clear model update. So there are like security questions over here with respect to like aggregation mechanism at the centralized server if it is a centralized federated learning environment. And if it is a peer-to-peer learning environment, also there are questions like how come the other model is getting converged, or uh, how can I trust the other model to give me the proper model update? So these are all the research questions with respect to the integration of federated learning with quantum circuits. And with respect to the base, like operating constraints, we have like scheduling also. So there are questions like how come you select the clients, on what basis you are selecting the clients, and also like how come you resource efficiently schedule the models, and how come you can like handle if it is a staleness. What is staleness? In a sense, like for example, in a peer-to-peer environment, I'm having like 6 clients running parallelly. So if two of the clients are giving the model updates later, and I'm trying to update that model update to my centralized averaging, then maybe that will be from rounds which is totally far behind my currently running round. For example, I'm running 10th round, and those two clients which is running slowly will give me the model update of the third round. Then what will I do? Like, should I incorporate that model gradient, or should I ignore that model gradient? So this is again a question, like how come you are going to come up with identifying the staleness, model staleness, right? So then again, there are questions like how to maintain the versions. Like there are multiple versions for the same model. Should I go with Git like of GitHub, like Git like structure? I mean tree like structure of model versioning. So all these questions are still existing, and but then there are more opportunities for integrating this. Federated learning environment with quantum classical environment with main motto is having a scalable distributed training environment. Why? Because running a very large data set in a closed network will take more time, like exponentially more time for making the model to be converged. Whereas when you run the same data set in a distributed environment, obviously the accuracy will also get increased, probably, or otherwise like the time of converging will definitely getting reduced when you go for this decentralized environment, right? So this is all about the open research challenges regarding the interfacing between federated learning and quantum classical environment. So let me move on to the next slide, where we are going to like deeply dig on what actually the federated learning environment is, so that we can understand the challenges of federated learning environment to come up with a proper interfacing mechanism, right? So federated learning, obviously, it is getting enhanced from the machine learning environment, right? Look, we are in the process of moving from machine learning environment to federated learning environment. So why do we need actually the federated learning environment? So in the modern data landscape, means like today's world of getting data in exponential range, voluminous data. So various information is distributed across the organization. So in that case, the modern machine learning needs data distributed across many organization and devices to come up with a proper convergence. So in that case, you can have examples like hospital. For a hospital, it can hold patient records of having like medical images, kind of scans and all, like data can be of different types. And as far as behavioral data is concerned, your smartphone is holding data like text, speech, sensor data, and your behavioral data, as I've already told you. So again, there exists a heterogeneous data here, which is of different forms, right? So when I take bank, you have like sensitive financial transactions available, and you have like kind of like account personal informations are there. So when it comes to vehicles and internet of vehicle systems, or internet of medical things systems, or internet of normal things, internet of things system, so here we can have like different variety of sensor data with different formats. Not only sensor data, like radar data as it is mentioned here, and data like multimedia data kind of thing. So there are like again variety of data, and in case of research labs also, people will have like sensitive data that should not be enclosed with the other person, but it sometimes it is necessary for the other person to know the uh, research data so that they can perform their own research. So there are necessity for these environments like hospitals, smartphones, banks, not only limited to this. So we have like multiple environments requiring data to be transferred to the other environment such a way that it should be like privacy preserving. So in that case we need to have this federated learning. But also, like when you go for centralized case of federated learning, then there are possibilities for a bandwidth to be intensive. Like it requires like more bandwidth for updating the model then and there for each round. So again, it will be expensive, and also it will be slow. Why? Because we need to have a proper coordination mechanism between the clients so that I can come up with uh, proper model at one point of time, right? So, and there are like different organizations participating in this federated learning environment where they'll be focusing only on, uh, like their business policies are taken into account. They should not share these things and all, right? So, even in the hospital itself, like when you go for a hospital, they are requiring you to take the test again from the scratch, and they'll be avoiding the other test which has been already taken in the other hospital, right? So these are all the things like those are their business policies. We cannot blame them, right? So on that case, so when you have this kind of uh, challenges existing in the centralized federated learning environment. So if you go for a peer-to-peer federated learning environment also, this problem exists. Why? Because like I need to have a separate coordination mechanism there. Like if it is a centralized federated learning environment, the central authority will be capable of coordinating all the rounds and all the clients simultaneously, which in turn pose risk when that centralized server gets crashed. So there are possibilities for a single point of failure in the centralized federated learning environment. So to overcome that, we can go for peer-to-peer federated learning environment. But then there are also challenges regarding like how to coordinate the clients were next round. So simultaneous rounds progressing is a question mark, means like research challenges there in the peer-to-peer federated learning environment. Anyways, so we are going to come up with the model from different clients in the federated learning environment. So obviously these are all the challenges we have already been discussed. So there are non-IID data where the distribution will be of totally different, like heterogeneous data. And even this is all about data heterogeneity. So there are possibilities for system heterogeneity also. So system heterogeneity. So in the system heterogeneity, the clients will have different architecture, different memory hierarchy, different computational capability. That is what I was telling you yesterday, previously. So if one client is running very slow, but it is converging with a good model convergence, still I'm in a question to incorporate that model, or should I like ignore that model? Again, this is a question, right? Maybe that model update will give you more accuracy. So then I need to come up with a point. Should I like include or should I ignore? So this again poses a major challenge. And communication, this is again a very big challenge where I need to come up with like repeated model updates, probably on each rounds or probably periodically. So this is based on the architecture, right? So this is again a question. And then like privacy leakage. So gradients and updates may leak sensitive information, even though we are not giving the raw data from our client device, but still the model or gradient is capable of mapping it to the raw data, underlying raw data. So again, this is a question, right? For example, there was one case like when we were doing research. So it is all about like if you have a metadata of an IoT device, you can able to come up with actual data. So you can, with the metadata, you can build up the data actually. So the same case is applicable to federated learning environment also. Like with the model, since it is derived from the raw data, I can able to reverse engineer and get the original data, right? So there are possibilities. So again, there exists a question for privacy preservation here, right? And also like robustness. So as I've already told you, for a 10 clients running in a federated learning environment, if two of the clients are doing combinedly injecting poison model or poisonous attack to the model, like poisonous data to train the model, then again there exists a question mark, like how to overcome this fault. So as you know already, there are different kinds of faults. One is crash fault in a sense. One client will be gracefully degrading from the environment, means they'll be like getting down in the network, and maybe after the crash it will be joining the network, or it sometimes cannot join the network. So that is fine. So detecting this fault is fine. We can able to do like in a very easy manner. You can identify this client and you can like make the client to come again to the network, possibly with other technical and modifications like algorithms to be running. But if it is a byzantine node, means like if it is a malicious node, then it will be passive attack. So it will be like simply injecting the poisonous model into the centralized model gradient without showing its identity. So identifying this byzantine node in the network is again a question mark, right? So these are issues with robustness, and also like large model constraints. So if you want to run your federated learning in the edge devices, then those are all like resource constrained environment, right? For example, if you are running something in a IoT device, if you are running something in a edge device, then those are all resource constrained devices that they cannot able to run this heavyweight models, right? So again, this is a question like how come you can make that model to run in a resource constrained environment, right? So when you go for quantum enhanced federated learning, this also poses a major challenge, right? So this is all about the federated learning, which we have already discussed. So there exists a neural network. So that neural, since it is a classical federated learning environment, hybrid federated learning environment, we have a neural network, and this will be the coordinating server. This is all about the architecture of a centralized federated learning, where this neural network will be running on probably like two or three clients, and they'll be aggregating in the centralized server. So the centralized server will run different algorithms like federated averaging algorithm. That was the baseline algorithm, and people are now coming up with different variations of federated averaging. Also people are coming with different totally different way of clubbing the model, converging the model, right? So let me come to the core point. Hybrid quantum classical environment. So we are currently in the era of NISQ, which is noisy intermediate scale quantum era. Noisy intermediate scale quantum era, which is near quantum devices are not yet powerful enough to replace the deep learning entirely. So you may all agree with me, I guess. So this quantum devices is not actually the perfect quantum devices, which are near quantum devices, and they are not powerful enough to replace the deep learning environment fully. So instead, we need to come up with a hybrid flow where you can have your classic computing for scalable pre-processing and quantum computing for enhanced representation of learning. So as I've already told you, like we use quantum here, we use quantum hardware for representing the learning environment, right? So probably the quantum part will give you a compact non-linear feature map, access to high dimensional Hilbert space representations, quantum kernels, and sometimes trainable variational quantum circuits. So the advantage for this quantum origin data are structured problems like privacy and security mechanisms, like formal analysis of variational quantum circuits. So, this variational quantum circuits are trainable models that can be optimized with your standard classical networks. So the flow will be, as I've already told you, the flow will be like classical pre-processing, quantum circuit, measuring the quantum circuit, and classical post-processing. So classical computing is for like scalability and data pre-processing, and quantum computing for enhanced learning representation of features and capability. So this will in hand go with the combination of classical advantages and the quantum's advantages. So so this is all about the advantages of having a hybrid model. So we have like compact nonlinear feature mapping, as I've already told you, and we have like high dimensional representation, not like limited dimensional as far as your deep learning is concerned. And we can also have note on kernels also. So this variational quantum circuits, this we'll be like exploring more in the uh, subsequent slides, like variational quantum circuits. So also, as I've already told you, like there are questions on like research questions on privacy and security mechanism, how to ensure the privacy and security mechanisms. Let me move on to the other slide. Like, why to combine this a hybrid quantum classical federated learning environment? Like, how come you can convert a deep learning model into a quantum federated learning environment? So, as I've already told you, again, the data are distributed, privacy and sensitivity prevent like centralized data sharing. So, when you come up with a quantum assisted learning environment, then you can able to come up with a complex pattern identification. So there are possibilities for your data to be represented in multiple representation, right? So on that case you can able to um, come up with like identifying the complex patterns. So which in turn give you like applications of having coordination mechanisms in the quantum assisted representation, optimization mechanisms. This can be in turn applicable to the environment like, as I've already told you, IoT sensing environment, multi organizational healthcare environment like Apollo, which is having like multiple different specialization, right, in different regions. So you can come up with exploring this multi institutional hardware and quantum sensor networks. So these are all things you can achieve through this combination of HQCFL. But the things to be noted here is when you combine this HQC and FL, like hybrid quantum classical federated learning, it cannot be like automatic quantum advantage. Like most near-term systems remain in the classical orchestration only. So, and we are going to add this quantum part only in the model components. Like we are going to uh, add this quantum components in the small model. So we have a strong classical baseline to have this hybridization. That is what my perspective is all about. So so this is the foundation of federated learning. So as you already know, this there will be like distributed environments. Clients train their local models on the local data, and this server in turn aggregates this model update. So when you incorporate quantum machine learning here, what will happen? So quantum machine learning, as you already know, it is where quantum circuits or quantum states are the part of a model or computation. So be clear that we are going to not adapt the quantum environment like fully, rather we are going to update or include the components of a quantum what is that, quantum hardware into our computation environment, right? So here quantum machine learning is all about quantum circuits or quantum states that are part of your model or composition. So in a hybrid classical model, both your classical trainable components and quantum trainable or computational components will be coexisting. Means like they'll be hand in hand work with the environment, right? So when it comes to quantum federated learning, so we have like quantum models, quantum data, quantum communication. It's all about quantum. So we have quantum models. We never going to tell it as a normal model. It is a quantum model, and the data will be like quantum data, quantum communication, and quantum computation. That is existing in the training environment, right? So in federated learning, each client, server, or both will be using hybrid quantum classical models and its subroutines rather than a normal model. So now we are moving on to finding out how we can manage or how you can at least change the aggregation algorithm running on the centralized server to adapt with the um, classical quantum environment, right? So with this, let me take a 2 minutes break. I want you to tell me like your understanding. The questions you can like so far the questions you can post it. Do you have any questions? Yes. So since I assume that you don't have any queries so far, let me move on to the other slides. So now we are going to change our classical federated learning foundations to a quantum enabled or quantum supportive or quantum assisted federated learning. So, when you have a normal federated learning environment, we have your global optimization objective, right? Like you cannot stop at anywhere you want in training a distributed model. Rather, you need to come up with uh, a point where you need to stop your getting data from the decentralized environment, right? So that should be a objective function. So the objective function will be like that involves a global model parameter vector and the local empirical loss of each client, and also the weighting factor given to the client's data sets. So since it is a non-IID environment, each client will be running different size of data, right? So based on that also you need to come up with the objective function so that you can stop converging to a model, right? Sorry. So, getting back to our federated averaging algorithm of a normal federated learning environment, and then we can move on to finding out how you can change this standard federated learning algorithm to a quantum specified federated learning environment. So we have a baseline algorithm workflow here. We are going to initialize the global model. So which is like I'm considering it as void of zero. So you can also come up with generating means like enhancing the model from a different accuracy level also. One of my student, like MTech scholar, is working on this environment where he is starting from model accuracy of 10 percentage. Like he's running this model in some other machine learning environment, and then he comes up with having that model to be enhanced in this federated learning environment. So he started with the model accuracy of 10 percentage. So it is all about the implementation criteria. Even you can start from zero also. This is what it is discussed here, like initializing the model, global model. So I am starting with like weight zero, and the server selects the participating clients. So first you need to find out the clients, like who are all the clients you're going to combinedly work with. For example, I'm going to work up with like seven clients. I need to first choose those seven clients into my environment, right? So then will be the first global model will be sent to the selected participants. For here, for example, let me have a notion of having, for example, I'm having some 10 clients here. For example, I'm having 10 clients here. And first, the global node will be sending model with weight W naught to all these 10 clients, right? So then the client trains locally for several epochs, and this epochs can also be set by the server intern. Like server can set the number of epochs for this client to be running this model for weight W naught. So, for example, you can set the epochs for each client as 10, or you can have like multiple epoch set for every other client also. That is also possible, right? So each client will be training the model locally, and they'll be coming up with like local models. So then it is the responsibility for the server to aggregate all the updated rounds. So this is what the aggregation rule is all about. So the aggregation reduces the communication. Like the rule is set in such a way that the Fed average mechanism reduces the communication compared with sending gradients with minimal batch. So its weakness is like the limitation is the multiple local steps can push the clients in incompatible directions when client data are non-IID. So if it is a non-IID data, means like they are running different sizes of data, then there are possibilities for the client to be moving in a incompatible direction, which means that they are coming up with like false accuracy also, right? So this is all about the base of your Fed averaging algorithm. So let me find out what are all the problems here, right? So first is, if you are using non-IID data, then there are two heterogeneous problems available, right? Means like affecting. One is the statistical heterogeneity, and the other one is system heterogeneity. So as I've already told you, this statistical heterogeneity, for example, one hospital is treating only the elderly patients, and the other hospital is treating only the pediatric cases of the elderly patients. So both are treating the elderly patients. One is like general um, physician, like general medicine concept. One is like purely pediatrician concept. So in that case, the data will be like differing. The type of data will be differing, right? The other cases like radar sensor. So some radar data will be on cars, and some radar data will be focusing on pedestrians. If it is like smart city or smart transport environment, right? And if it is a bank, then retail transactions are also available. Corporate transactions also available, right? So individual accounts are there, business accounts are there, right? So even the type of data is same, but not a type of data. Even what is that? The base of the data is same, but the type of the data is differing, right? So in that case, we'll be coming up with different model updates, means inconsistent model updates, and uh, eventually the global convergence will be getting lower, and there will be difficult for generalization and fairness also, there can be like way of skewed model generalization also, right? So this is all about statistical heterogeneity. If it comes to system heterogeneity, then sorry, then the clients have like different CPU configurations, CPU architectures, CPU, I mean, address paths, and there are GPU CPU compatibility issues, and memory size, network bandwidth, even battery uptime, downtime, everything is considering, like means the hardware nature of the system is also giving its impact in the model convergence. So obviously, the result would be like some clients will become slower, some clients will become like unreliable, and there are like communication bottlenecks also. So this is the problem that is existing with the normal federated learning environment itself. So when you try to combine it with quantum federated environment, then again it poses a very big challenge. So here you can see that in a federated learning environment, heterogeneous problem is there. So now it gets elevated to quantum specific heterogeneity. So this is beyond your classical federated learning. So what are the heterogeneity here? Means the quantum devices are uh, different from their qubit counts. They are different from their noise profiles, and there are different gate sets also. And the connectivity, hardware connectivity of the network will be differing, and there are problems with budget also. So a simulator with a cloud QPU and local quantum accelerator would be a, again there are variations, right? When I try to run a quantum algorithm, for example, the quantum federated averaging algorithm is like I'm proposing, and I'm running in a simulator. So, for example, I'm running it in a Qiskit simulator, right? So that results will be differing from the results produced by the clients, which is running in the cloud-based processing units. For example, I'm running some clients in the IBM's QPU, like quantum processing units. They'll be differing in a different way. Their behavior will be differing. Why? Because they are running in the actually like somewhere in the remote, right? I don't know the configuration of the QPUs. Even I know the configuration of the QPUs, but still I cannot have a map between the results produced by that client and the environment where the QPU is hosted. So that will be giving you different variation of the result, right? And if at all I'm running it is in a quantum accelerator in my local machine, that will be differing in its own way. So how come I can have a benchmark between these three things? Same quantum algorithm with same client configuration running on three different areas will give you three different way of interpretation, model interpretation, right? How to have a point of understanding here. So again, this is a problem, right? So obviously, the heterogeneous problem of federated learning will be coexisting in the HQCFL also, along with the communication challenges and optimization instability also. Why? Because the hardware is getting evolving day by day, like quantum hardwares, right? So the testbed configuration is also getting uh, varied. So in that case, we need to come up with a point how to have a balance between these three. So the main disadvantage here is there are quantum hardware variabilities, and there are noise sensitivities, and there are also like resource imbalance. So while you are coming up with a quantum assisted learning algorithm, you need to have these three things in mind. One is the different variations in the quantum hardware, and
sensitivity, noise sensitivity level, and the resource imbalance. So this is the thing you need to have in mind. Also, eventually, when you have a quantum federated learning algorithm, so there are different performance metrics also. The first being scalability. So, as the main motive of any distributed kind of learning environment is scalability, right? So, you need to have a trade off between scalability, fairness, and the communication cost, right? So there should be a trade-off between these three. So you cannot simultaneously increase your scalability and the communication cost. Why? Because if you increase a number of systems for a network, for example, I'm having a network with 15 system and I'm in a plan to add 5 more systems in a quantum learning environment, which is horizontal scaling. So in that case, the communication cost will obviously increase for each round, right? So previously I was communicating with only 15 systems. Now, when I add 5 more systems, obviously that 15 systems need to communicate with these 5 more systems, creating a exponential communication cost, right? So I need to have a proper trade-off between scalability and the communication cost. This is also a problem. So as far as HQCL foundations means, like, what are the low level problems or issues occurring when you are trying to interface this federated learning with quantum computing. So as we already know, the qubit exists in a superposition. So we'll have like um, superposition environment, like zeros and ones, not only exact zeros and ones, and the amplitude also satisfying, like this which is equal to, means like the measurement returns classical outcomes, usually zeros and ones for a measured qubit. So we are going to make that qubit in our regular environment, right? So we are trying to measure this qubit in a classical outcome. So typically, again, it collapses back to zeros and ones as far as our normal data representation is concerned, right? And also, the state's probability amplitude will be based on the zeros and ones it is producing. So in machine learning, the measured statistics are used for features, logits, and expectation values or kernel entries, right? So you can directly map this HQCL to your machine learning environment. So then is parameterized quantum circuit. A parameterized quantum circuit, which is also known as variational quantum circuit, which is, I have already told you this before, variational quantum circuit. So, sorry. So this variational quantum circuit is otherwise known as parameterized quantum circuit. So it has parameters that are tunable. So this tunable parameters can be optimized, kind of hyperparameter optimization can be optimized during learning itself. For example, if you want to uh, change the quantum state based on the input data, you can also change the learnable parameter theta during your training also. So the state will be, as I've already told you, we are going to map the qubits into, again, traditional typical zeros and ones. So then obviously you can have the prediction function also. The model prediction function is obtained through the quantum measurements, where the observation is based on the output corresponds to an expected value extracted from the quantum systems. So then is like input encodings in the QML, like quantum machine learning's input encodings. So there are like six basic encoding mechanisms. So first one is basis encoding. So this basis encoding encodes the binary strings into a computational basis states. So as I've already told you, we are going to not actually zeros and ones, but a basis state. So this is simple, but we cannot use this for a real value data. So the motive of our work is to initialize or to have a high level representation. Then how come you can have this kind of encoding? So this is a basic encoding for understanding, but which cannot be utilized as it is for a real world encoding environment, right? So next is angle encoding. So angle encoding encodes the features in the rotational angle. For example, you can apply, let me give you, you can apply this rotational angle for a function y of uh, xi to qubit I. So this is one example of uh, mapping a rotational angles to the uh, qubits, right? So this particular encoding mechanism is noise friendly, means NISQ friendly, and it is uh, used in like simple quantum neural network QNNs. Okay, then amplitude encoding. The third one is amplitude encoding. So this encodes a normalized classical vector into a quantum amplitude. For example, the representation capacities for n qubits, you can have like n 2 to the power of n amplitudes. So this amplitude encoding is actually computationally I mean expensive. Why? Because the state preparation itself is a costly one. Like cost wise, it is not effective, right? Like why? Because for n qubits, you need to have 2 to the power of n amplitudes. So this is three basic encodings. Then we have like other two data re-uploading encoding. So repeatedly we'll be injecting the classical features across multiple circuit layers. So sorry, you'll be injecting the classical features into the multiple circuit layer. So this will be useful when your feature dimension exceeds the qubit count. For example, um, in an environment where your dimensionality of a feature is getting increased as uh, per the circuit or configuration of your quantum circuit, then you can go for using this data re-uploading encoding, right? So it improves the expressive power of shallow circuits. Means my circuit is shallow circuit. I can able to make that shallow circuit to represent like high dimension of the features. So this is also possible. And the last one is like quantum feature maps. How you have feature map in this classical federated learning environment. So this quantum feature maps transforms your classical data into quantum states. So this is something like a representation. Your classic data will be represented in the quantum states, not qubits, quantum states. So this is actually being used in the variational quantum circuits, which is already being discussed, and the quantum kernel methods also. The last one is quantum gradient. So this again we have like barren lattice. So next 1 minute. So the quantum gradients are like parameterized quantum gates where the gradients can be computed using the parameter shift rule. So the parameter shift rule is stated here. You can see this the parameter shift rule. So this is the parameter shift rule. So instead of directly differentiating the quantum circuit, we are going to evaluate the circuit at um, theta. Theta is a learning parameter. So theta 5 by 2. So it includes like this computes the difference between two outputs. So the scalability implication here is if a quantum layer has p trainable parameters, naive gradient estimation may require like big O of P, which means like complexity of big O of P or big O of I mean twice the P. So P is a trainable parameter, twice trainable parameter, the circuit evaluation per input or per batch. So that is already been discussed, right? So with finite shots, each estimate has sampling noise. Communication rounds plus quantum circuit execution can become expensive when you go for this naive gradient computation. So federated communication rounds will get increased when you go for this like quantum gradient. So this need to be considered, right? So it is not something like your normal model gradient. So for a quantum model gradient, the complexity is increasing based on the trainable parameters. So the last one is barren plateaus. So barren plateaus are training regions where gradients become extremely small. Often it is getting worsening with the qubit count. Like when you increase the qubit count, it is getting the barren plateau is getting worsening. Means like it is getting worse. And also if you try to increase the depth of the circuit also, this will be getting I mean affected, right? So the things that need to be considered here is like you need to avoid unnecessarily deep random circuit depth. Also use the hardware aware circuits. You cannot like generally use the circuits which is not designed for your requirement, right? So and also the quantum layer should not be much. So when you have the less number of quantum layers, then you can have like proper output, right? So also you need to have a layer wise training that initiates in a good pace, and also the cost functions need to be locally defined cost functions, and quantum naturals means like quantum adapted gradient methods for a appropriate value, right? So this is a general common architecture so of HQCFL. So as I've already told you, this is all about centralized environment. So I'll be having like clients running the local data. So there will be a classical encoder. This classical encoder is like normal classical environment. It will be generating you a function called h. So based on the given input data. So again it is fed to the quantum layer. The quantum layer will be generating a function called um, is it so it will be generating loss and update. So the classical value will be encrypted and this encrypted model update will be given. So rather than passing the model update, even the model update as it is, uh, so since we have discussed earlier, like the model updates will also have a map between its underlying raw data. So when you try to send the model updates as it is, there are possibilities for your privacy to get questioned. So in order to avoid that, we are going to encrypt the model update also. Please try to understand the raw data will be sorry. The raw data will be running on the local machine, and its model update will only be transferred to the centralized environment. Even then, that model update is transferred in an encrypted way, right? So that should be encrypted model parameters. Then in the client, sorry, in the server side, as usual, client selection will be done. So and the parameter distribution should be done. So client will be distributing the data size. Client configuration, whether it is queued or unskewed ID data. All these things are decided by the centralized server. And then we have like model aggregation to be run here. So this could be like quantum federated averaging environment, which we'll be discussing in the next slide. So then we have like evaluation and the logging of whatever the thing done by the client. So you'll be getting at the new global hybrid model. Why it is said to be hybrid? In a sense, it is combining your classical encoder's output and its quantum layers, passing this encoder output into quantum layers, so generating this quantum hybrid model. So as I already discussed to you, you need to be here more concerning on having a less number of quantum layers, and the depth of the circuit should also be important while designing this architecture. So things to be remembered is the layer of quantum here and the depth of the circuit, also kind of encryption mechanisms, like type of encryption mechanism here. Like this is not that much important. So based on the requirement, you will be deciding on. But for an architecture to be concerned, like HQCFL architecture, the things to be noted here is the quantum layer should be of like very less to have a proper model convergence. So this is the thing what we were discussing from the starting. So how to convert your federated average algorithm into a HQC, like hybrid quantum computing compatible federated averaging algorithm, right? So this is the normal objective global, this is the global model optimization objective. So we'll be starting from the from here only. So as I've already told you, we'll be uh, running on a function called h, which is you can see here, which is classical encoder. Classical encoders output. Then we have like quantum layers output. So this will be passed on to this quantum layers and will be generating the model gradient here as y dash with a loss of y dash comma y. So this need to be calculated for the last function, right? In order to analyze whether my model is converged in a proper way or not. So anyway, this is what we'll be calculating. So the logic of the hybrid federated averaging is same as that of your normal federated averaging. You can see here. In the normal federated learning also will be doing the same thing, right? But here the client will be running only the epochs that is trained locally. But here you can see it is passed into the quantum layers. So the quantum layers will be generating the gradient, and this gradient will be compared with the normal value to come up with the loss function, right? So initially we are going to I mean, initialize the model weight, and for each round from 0 to t minus 1, like we'll be selecting the client that would be done by the server. So the server will be selecting the clients and it will be sending the initial model update. There you'll be sending W naught. Here will be sending, the server will be sending the value of W naught, which is like initial weight. Here we'll be sending the update like phi, theta, and this psi, and also the circuit schema. Why? Because as I've already told you, the client will be differing in their own way based on the circuit's configuration, right? So first, as a server means centralized authority, they need to come up with the circuit schema to the client. So it will be sending the circuit schema along with these three things to the clients. The clients in turn will be, for each selected client in parallel, they'll be doing parallelly local training. So that local training will be again the hybrid training of generating H value, passing it to the quantum layers, so then computing the model gradient. So they'll be running all these in the hybrid local environment, and again it will be sending the update to the server. So the server will be aggregating all these weighted parameters in this way. Means they'll be aggregating all the parameters separately, phi separately, theta separately, and psi separately. So they'll be coming up with alpha also. So the server will be aggregating all the weighted parameters, and it will be moving on to the next round. So this is for round number one. Then again it will be going on to round number two. So again it will be sending on. This will be repeated till like t minus 1, and this t will be decided by the server. So this t will be decided by the server based on certain parameters that is already being discussed, right? So the model will be running for some n number of rounds that is decided by the server, and at last the model will be evaluating the global model. So where and all you can use this federated averaging environment. So why? Because like it's already been discussed that the federated averaging environment is a baseline or standard algorithm that is already been used, but still there are disadvantages or limitations in this federated averaging also. So based on that, what are the conditions or where and all you can use this environment? So where and all, in a sense, like clients share identical model architecture. Means like this circuit schema should be of identical for each client, so that you can come up with a proper global model with good accuracy, right? And also the heterogeneity should not be like wide range. It should be a moderate range of data heterogeneity, right? And as I've already told you, this quantum layer should be small in order to have your um, this particular experiments to be executed, right? And also this way of federated averaging should be a baseline experiment. So as already told you, people have proven this federated averaging is not uh, getting a good feedback in all the other environments also, right? So this is all about federated learning, means like federated learning spread averaging algorithm implemented for HQC, which is hybrid quantum classical quantum algorithm, right? So there are different parameters here like QNN classifiers with hybridization, and there are quantum transfer learning in federated learning. So normal transfer learning is like with a small amount of data training on some other environment, the model will be updated for the other environment, like adapted for the other environment, right? The same way quantum transfer learning is also available, and there are like federated quantum neural network also, and federated learning also. So this is all about the different model variations in the HQCL environment. So this is all about for this session's presentation. So the session is out for any queries. Sir, the session is out for any queries. So, as for the research direction is concerned, you can have research questions on like means that this there are open challenges and research queries existing on the interfacing between quantum hardware. Like why, as I've already told you, we are not exposed to much quantum hardware. Rather, we are going to have the small layers of quantum is enough for having a great HQCFL architecture. So the architecture is all about, as I've told you, like we have quantum layers, and that layers are should be minimal. So with this, you can go for adapting your HQCFL architecture based on your requirements. So you can. This is all about the configuration. You can uh, have a custom configuration based on your requirements, and also this is not about restricting your aggregation to only federated averaging, as the researchers have already proven it is proven that Fed averaging was not much applicable or much uh, available to any other requirement. Also there are different averaging mechanisms, not averaging, like aggregation mechanisms available for the centralized server, and there are also different configurations with peer-to-peer federated learning also. So far we have discussed only like centralized federated learning for hybrid quantum computing environment. So there are possibilities for having a peer-to-peer architecture involving without having any centralized way of aggregating the models. So this is all about from my side. So if there are any questions, we can proceed, or otherwise we'll wind up the session for now. I think there are no questions.
Thank you, ma'am. And next 11 o'clock, we'll start the next session, ma'am. Their participants will soon will share the feedback link. Again, we'll come back at 11 o'clock.
please update the pending works. Okay, the CO3 today we need to update marks. So many pendings are there. 14. No need to get correction. Write it and then upload it. Yeah.
Welcome to the next session, ma'am. Shall we start the session, ma'am? Priya, ma'am.
Ma'am, ma'am,
Yes, ma'am.
shall I start, ma'am?
Yes, ma'am.
Okay.
Continue this session.
Okay. So, the previous session we were dealing about hybridized way of interfacing your normal federated learning with small quantum layers called, so that we can come up with like classical quantum hybrid federated learning environment. So in this lecture we are going to see about like how come you make that architecture as a scalable architecture, along with like what are the ways so that like you can like focus on the research challenges in this QFL, quantum federated learning. So let me first introduce you to quantum assisted federated learning. So previously it was like we have incorporated in small components of quantum into our federated learning environment. So um, here we are going to make our quantum as a real-time assistant with the federated learning environment. So, as we have already discussed, federated learning will be training the models across the distributed clients without centralizing the raw data in global server, right? So this path of training the global model will be working out in healthcare, finance, even in mobile devices to acquire their behavioral data, autonomous vehicles, and several IoT architectures ranging from industrial IoT, international means like what is it, IIoT and IOMT and normal IoT environment. Also, like uh, it can be useful for training the SAR images in the satellite networks and cross organizational analytics, as I've given you an example of Apollo group of hospitals, right? So, as I've told you, we have problem of heterogeneity that persists even in HFL, like HQCFL. So there is a range of heterogeneity like statistical and system heterogeneity, along with communication cost and even privacy leakage in the normal, even in the federated learning. Then if you are communicating the model updates, even the, not even the raw updates, but still there are possibilities for privacy leakage, right? So this quantum assisted federated learning asks whether quantum computation can help with one or more of these challenges while retaining the privacy and decentralization, which are the core idea or core advantage of federated learning. So, how come this differs from your normal learning is in our classical federated learning environment, all learning computations are classical. So, as I've already discussed in the previous session, so everything is a classical, means like you are going to run the neural network algorithm, right? So, in the quantum federated learning, the federated learning is employed where the model or training process includes quantum computations. There, the layers alone is a quantum layer, and the model will be passing through the quantum layer. But here we are going to includes a quantum computation. Then, what is quantum assisted federated learning? So, quantum assisted federated learning is a broader term where the quantum resources can able to support feature encoding, kernel evaluation, optimization, even privacy, communication, or security. So previously in the HQCFL architecture, generalized architecture, we were externally imposing the encryption mechanism to have our model to be secure, right? But here, our inbuilt mechanism itself, like quantum assisted FL learning itself, will give you the highest level of security. So this learning pipeline can remain hybrid, classical plus quantum. So we are not again pushing into more quantum environment. Rather, we are going to explore the quantum facilities for our hybridized algorithm, right? So QAFL is not a replacement of classical federated learning, but it can be best viewed as a hybridized system for the design problem, like using classical federated learning for orchestration and inserting quantum modules where they can have a advantage of quantum in the federated learning. It is not about moving towards purely or inclined towards federated learning. Rather, we are going to utilize the pros advantage of quantum environment in the federated learning architecture, right? So in the normal classical federated learning, we have, as I've discussed, that will be like collaborative way of training the data, right? So in the quantum machine learning, we are going to use the quantum principle to enhance the learning representation, right? Like and feature representation and learning components. So we are going to combine the advantages of both of the environment to come up with like quantum assisted federated learning, right? So as we have discussed one part of heterogeneity problem, where the federated averaging will give you the problem when there is like more heterogeneous non-IID data, right? So in the previous session itself, we were discussing about uh, the divergence, like heterogeneous data, and the level of impact of it in the architecture, right? So here there are other algorithms than federated average algorithms, like FedProx. Prox is like approximity, like approximation algorithm. So federated approximation algorithm. So it also have its local objective function, but uh, the problem is like when you again combine this QAFL, quantum assisted federated learning, the quantum clients will have again heterogeneity that differs on like qubit counts, gate set, like native gate set. For each client, there will be like native gate set, right? The native configuration, gate configuration. That will be again differing. So there will be variations of uh, gate configurations in the clients, and their noise profiles also in turn will be differing. So you need to come up with a proper approximation noise profiles to have added to the model, right? So then you need to find out how come you eliminate or how come you approximate this noise profiles to come up with the proper model aggregation. Also, there will be different queue delays when you are working with like cloud QPUs, like quantum processing units which are residing in the cloud. When you are using it, there will be obviously communication cost and the queue delays on using it, right? And also there are circuit compilation outcomes also. Fine. So with this note, we need to come up with a point where we are going to explore on the different architectures of QAFL. So that deals with all these ranges, like different patterns of having this quantum assisted federated learning. It is not adaptive, it is assisted. Like we are going to get the advantage of quantum and we are going to apply it in the normal FL architecture, decentralized architecture, right? So I have like 5 variations. Apart from there are like different, totally 8 or 7 different patterns also there. So you can come up with your own based on your requirement. So the components will be same. We are going to mix and match, kind of combinatorial play. So you can come up with a new architecture that will be like giving the best optimization for your own requirements and your nature of your data, right? So this will be differing from five different ways. One is like client side quantum learning, where the quantum learning environment will be forced onto the client and server will be doing the same thing whichever it is doing in the normal federated learning environment. And cloud quantum integration is what we were discussing now. Like you're going to utilize a QPUs that is residing in the remote cloud, and you will be working on the integration of federated learning and quantum QPUs, which is running in the cloud, right? So then there's like split federated learning and vertical federated learning. This is a very like research oriented environment where we can explore multiple problem statements to be encountered here. This is split and vertical learning. And then we have like hierarchical scalable architectures where you have multiple architectures running like hierarchically, so that it will be giving you the advantages of multiple architectures together and eliminating the limitations of one over the other, right? And the last one is decentralized quantum federated systems. Again, um, as I've already told you, there are problems with centralized federated learning where it will be like overloading the server, and there are options for the server to be compromised, and there are options for the server to get failed, eventually affecting all the nodes in the network. These are also possible, right? So we are slightly moving towards like peer-to-peer federated learning systems. So that is what is called as decentralized quantum federated learning, where means systems where you are not going to have the centralized server anymore. Rather, you are going to give the authority for each and every node as same as such, right? So the QAFL architecture, as we have discussed, it will be integrating the normal federated learning environment and hybrid quantum classical machine learning, which has already been discussed, and distributed optimization to come up with reducing the number of rounds happening for a model convergence and the time to uh, converge a model. And how come you decide on the number of clients that need to be in a system architecture, and also like how to run algorithms which is privacy preserving in a environment. So the concept of distributed AI, so running your artificial intelligence algorithm or machine learning algorithms in distributed systems rather than running it on a single system, right? Kind of uh, decentralization with uh, running an algorithm, AI algorithm, right? The objective of this is we are going to enable like multiple distributed clients to collaboratively train a model. This is what we are going to do in the federated learning environment also. So what makes us to move towards this QAFL is like we are going to use the quantum computations to make the convergence time of a normal federated learning to be faster, at the same time attaining a normal accuracy, means like standard accuracy, right? So we are going to anyways keep the data local, right? The system will be running the clients will be running the model locally, but the computation will be of a quantum computation. This in turn will improve the representation of learning and optimization with respect to your model convergence. So I come up with like different architecture pattern of QAFL. So here the pattern will be differing from one among the other based on this design variables. So based on this design variables, all these things into consideration, one pattern is differing from the other pattern based on this. Like so we can first designate on the quantum execution, where the quantum execution occurs, either in the client side or in the server side, or if it is a peer-to-peer learning, who will be the authoritative for running this quantum execution, and to find out whether all the clients are having their quantum hardwares, or some of them are quantum enabled systems, some are quantum disabled systems. So there are possibilities, right? So based on this, we are going to design the pattern, so where the quantum execution occurs. The second point is communication topology. Like, are we going to implement the topology um, with mm, with every node communicating with every other node in case of your P2P federated learning environment, or it may be like one-way communication if it is a centralized federated learning environment, or it can be a rounded way of communication. There are possibilities, right? So in what ways the clients are getting connected, or in what ways the server is connected to the client environment. So this also plays a major role for this QAFL architecture, right? So then we have like privacy boundaries, like uh, means like one for example, one client can communicate with its neighbors rather than it should not communicate with the a neighbor which is residing so far from it. So these are also possible. That what is the privacy boundary for this communication, and resource centralization? Who will be holding the resources for this communication? Either server or each client. So this is again a question mark, right? And the scalability mechanism. So the main theme of this presentation is how to improve the QAFL architecture towards reaching the maximum scalability without compromising the communication cost. As we have already discussed in the previous session, there should also be a trade-off between the communication complexity and also the or is that scalability architecture. So if you try to push the scalability, for example, I'm trying to vertically scale my system, means like I'm increasing the hardware and try to scale my system not horizontally, vertically. So if I vertically scale my system, even then I'm not adding much uh, nodes to the network like vertical scaling, but still it affects the communication cost. Why? Because in a vertical scaling environment, number of nodes will be getting increased, which in turn obviously increases the communication cost. But what makes the what is it vertical scaling of a node that impacts in the communication cost? That is also a question mark, right? So based on all these design variables, we come up with some seven design patterns here. So based on the quantum execution location, will be differing among the patterns. So in pattern A, it is a client side quantum execution. For pattern B, there will be like quantum cloud backend, which we are accessing through remote connection. So there will be a cloud where our execution will be done. That will be taken as the backend, right? So in pattern C, we will be focusing on server side quantum computation. So the server will be taking care of all the communications and also the um, architectural configurations, right? So in pattern D, we'll be focusing on split of client server hybrid, like one set of functions will be carried out at the client and the other set will be carried out at the server. So kind of splitting the workload between client and server in order to avoid overloading of the server in the environment, right? So that is all about pattern D. In pattern E, we are going to vertical FL, means like as I've already told you, one of the major system can be of server, so it can be vertically scaled so that it will be focusing more on its computation. So then is your hierarchical edge cloud QPU, where there will be a hierarchy where your QPU will be running in the cloud, and then we have like devices, and then edge devices will be communicating to the other client. So there will be a hierarchy like tree like structure. uh, in the top we'll be having QPUs, and then we have like cloud environment for communicating, means remote connection, and then we have like edge computing, which is probably wireless or wired communication. And then we have clients which are distributed in the environment. So this will be the hierarchical order for pattern F. And in pattern G, which is a decentralized peer-to-peer, which has no server at all, every node will have the same level of authorization, authorization inside the network, right? So typically, what are the use cases this patterns can be applicable for? For pattern E will be like, which is a basic one that can be applicable in the simulators like Qiskit, and for the research demonstration or experimentations. In pattern B, we'll be using cloud, which is something like a near-term deployment, but it's not quantum environment, right? So in pattern C, we'll be having a centralized quantum optimization. Why? Because the server will be taking care of every nuances that is being imposed in the architecture. So in pattern D, this the way of splitting the workload between client and server. So this way of hybridization will probably help in multimodal systems where you have like different heterogeneous data to be trained. So probably it can be used for mission critical applications like healthcare, where you need to focus more on accuracy rather than your time, right? So since it is a mission critical application, we need to have like have more accuracy. So convergence time can also be increased so that I can yield a proper accuracy here. So in case of time critical application, the accuracy can be compromised somewhat, but it needs to have a proper convergence time, which should be very less than that of the other, right? So that is what this is all about, split client server hybrid. And in pattern A, we have like vertical FL, where the feature will be partitioned among the institutions, several institutions. So instead of having the partitions of model, we are going to partition the features, right? In pattern F, we are going to have a large scale deployment. Why? Because we have like hierarchy, so everyone is taking care of their own functionality. So the workload is divided among the hierarchy, and we can able to accomplish a large scale experimentation here in pattern F. So obviously this can be used for multi-institutional purposes. And in pattern G, since we are not supposed to have a trusted decentralized environment, we cannot trust the server as such. We have this peer-to-peer environment where we'll be having a collaborative learning. So each one will not have a trust on the other client. So this is all about pattern A, which is client-side hybrid quantum neural network as an example. So here the quantum execution will be on the client side. So each client will have a classical encoder, which has already been discussed in the previous session, right? We have a classical encoder, and we have a quantum layer, and we have like classical head. So this will be something like your mm, thing which has already been discussed in the previous session. So the server will be aggregating the classical and quantum parameters. So this is applicable for the environment where the client with local quantum simulators and the edge devices with access to small quantum accelerator. So this is, as I've already discussed with you, this is applicable for research purpose only. Why? Because as we discussed in the previous session, this is something like your classical federated learning as such. As an extra thing, we have included a quantum layer, and this model will be passed through the quantum layer to get the output. So nothing more. Like we are going to just utilize the components of the quantum. So this will be used for the basic research purposes. But the challenges existing here is um, circuit compatibility. Means like all the clients must have a proper circuit compatibly, means the configuration should be of same for all the clients. So that is the need here, or otherwise it will not uh, uh, form the network, right? And also the quantum gradients are expensive. Why? Because since the client will be more architecture, mean more infrastructure oriented, so obviously the quantum gradients are like cost oriented also, right? And also since it is hardware oriented, means infrastructure oriented, there are possibilities for hardware noise, and all these hardware noise for different clients will be differing. Why? Because like someone have like a different way of having the architecture, but the other will have a different way of interfacing the architecture, right? So normally a client will train a hybrid model locally, and it will be uploading the updated classical weights to the quantum layers. So this quantum circuit parameters will be decided on the quantum layer, and it will be forwarded. So the server will be aggregating the parameters. Uh, Normal federated averaging, for example, used by the classical way, and in for quantum we'll be using parameter averaging, as we already discussed in the previous session. So the updated global parameters will be sent back to the clients, and the client will keep on updating the model variants, and it will be sending it to the server. So this is all about pattern A. So pattern A is useful only for the research and experimentation purposes. So the federated aggregation of both classical weights and quantum circuit parameters are happening, and also this will be helpful for personalized learning environment, where the quantum will have its like way of representing like multiple dimensional representation. Then we move on to pattern B. So pattern B is where the clients will be having normal execution as such of your normal federated learning. So only the server will be running the means like quantum environment, and also it will be running in the cloud. So client will keep the data locally, but quantum backend will be called for circuit evaluation. So first, the client data will be pre-processed in the classical manner at the client locally, and remote quantum execution API will be updating and local update to the centralized server. So client side everything will be same as that of what we are doing in the normal federated learning. So client will be its data will be staying local, and the pre-processing kind of like feature extraction, encoding, and circuit parameterization will be passed to the cloud QPU. So it is actually kind of near quantum deployment, where uh, the server will be running on the cloud. So the clients cannot have its own quantum hardware. So there is no necessity for the client to have the quantum hardware, which is in turn beneficial for us. Like if I want to be a client and I want to run a want to be a part of a quantum network, then I can be a part without having any quantum hardware in my hand. Rather, I'll be using the whatever the provision given by the cloud quantum providers, right? So because the server will be only running on the cloud environment, which is the kind of accessing your AWS EC2 kind of thing, right? So you are going to just compute in the cloud, and we are having the same local hardware configuration, not necessary of having hardware that is compatible of running quantum algorithms. So the challenges here is like there are again challenges. The challenges here are the QPU Q latency. For example, the cloud quantum service provider is capable of handling some 12 to 13 clients at a time. If more than 20 to 25 clients are trying to push their boundary towards accessing this QPU cloud, then obviously the latency will be getting increased. So obviously those who are initiating the request will be queued in the QPU, right? So obviously the latency will be getting increased because I need to establish the remote connection to the QPU, and the QPU will be computing my whatever model updates or gradients or initial weights. So they'll be doing the computation again that need to be dispersed to me, right? So this way of remote connection establishment, remote way of computation and getting back the result will obviously have the negative impact in the latency. So also when it is traveling from my system to the other system, means which is cloud, there are again exposure to privacy risk also. So we need to definitely have encoding mechanism or encryption mechanism in this case. So it is a need now, right? So there are possibilities for my circuit to leak the information. So obviously my uh, best part is I should encrypt my algorithm, means I should encrypt my own model update so that it cannot be overseen or it cannot be captured by others while on transit from my local system to the cloud, right? So again, there should be whatever the things for a cloud requires, it will be applicable here also, kind of access control, also kind of like secure transportation and transit, and also like masking way of computing. So because it is running in the remote area, right? So anyone can see the thing that is running in the remote. So I need to have a proper way of like blind computation also. So these are all the things that need to be considered here in the um, architecture. So this architecture is where the clients will be running a normal federated learning algorithm in a normal federated learning environment, but the server will be running in the cloud which is capable of having a quantum hardware. So this is all about patent. So next is pattern C. In the pattern C, we are trying to have a server side quantum aggregator, which in a sense like clients will train the classical models locally as such in the previous pattern. But the server, which is not in the cloud, it uses like quantum assisted optimizations alone, like clustering, kernel evaluation, and proper secure way of aggregation. All this, like only the properties of quantum aggregator will be deployed in the server, but the server is running locally, not in the cloud, right? Server will be any distributed entity, so that is capable of having a quantum aggregator, not a normal Fed averaging or aggregation. So this will be kind of a quantum enabled aggregation where it will be using like optimization mechanism, clustering mechanism, and all, right? So this the client will be normally running the same thing, right? So in you can see in the architecture itself, the quantum assisted processing is capable of having all these features, but still it is a centralized environment. So uh, the server, while on receiving the client updates, it will be making it to pass through this whole quantum assisted processing, and then it will be aggregating, and this aggregator is purely a global, means like quantum enabled global aggregation, right? So what is the advantage of having this architecture is like you can include edges here. Why? Because this part will take more time, right? Since it is a quantum processing, this part will not more time. The complexity of this part is in getting increased. So inclusion of edge will have its benefit over here, right? Also, the quantum resources here are centralized with the coordinator itself. So this coordinator can be capable of doing anything with these clients, right? So this, which in turn indicates that this federated server will have its both pros and cons in this architecture. Fine. So, what is actually the limitation in this architectural pattern? In a sense, if only the server uses quantum computation, privacy, and client side representation, the clients who are running this will have their local model updates, which are not computationally stronger or not computationally uh, richer in representation. So again, it comes something like a normal federated learning environment, right? Only thing is we have like quantum assisted processing only that is being incorporated in the federated server. Fine. So this is all about pattern C. Let me move on to the other pattern, which is pattern D. So this way is kind of hybrid. So we are not going to push the quantum only on one side, not towards the client or not towards the server. So we are going to split what are the things that need to be done by the client, what are the things that need to be client by the done by the server. So we are going to split the model. So there will be a local encoder or a quantum feature encoder inside a client, and server will be the shard head aggregation, and it will be fixing the objective also, global model objective also, and it will be fixing the global classifier also. The clients will be like sending the embeddings or activations, like not actually the model updates. So this will be sent to the server. So this server in turn will be like running your model aggregation same as that of your normal server, right? So instead of having a normal classifier, here you have a global classifier and federated learning embedding. So this will be something like the client will be running the encoder in its part also, and the federated server also will be running the quantum components in its own point. So this will be a kind of hybridization where the client will also have the quantum components embedded, and the federated server will also have its own set of components embedded into it, right? So it is best for healthcare and vertical collaboration, as I've already told you, when it is like multimodal data available, so not a kind of single source information. When you have like multiple source of information employed, then this way of splitting the responsibilities between client and server will work out, right? But again, there are risks also, means limitations of this architecture also. Why? Because this architecture um, still the client builds the model and activation that will leak information, or at least it will give you the inference from what the model is being built. So it will in turn give at least the um, clue of what the raw data is all about. So again, it poses a privacy question mark here. And also we need to impose extra encryption mechanism, or case of different infrastructure oriented or hardware assisted tools at the client, in order to make them to have a secure way of communication and secure way of sending the data from its local server, means local place, to the server, right? So this will probably increase the what is that architecture's complexity, right? So this will not work out for a long term classification or long term federated learning environment. So it give you global learning on rich representation, but still like, rich representation compared to the basic pattern, like previous pattern. But still, there are disadvantages of having an extra algorithm for securing the data at the local end, or also like securing the data during the transit from the local client to the sender, means like server. So next is the other pattern, which is vertical quantum assisted FL. So this vertical federated learning is used when the entities share overlapping data or overlapping configuration kind of thing, like sharing the infrastructure. So, but the feature columns will be differing. For example, the example given here is hospital. So you can see that the hospital lab, we have scanning, place for scanning, place for taking echo, place for taking the ECG. So have like different features for the same patient. So same patient, if he goes for scanning, for example, ultrasound scan, so the output will be different. If he goes for the same scanning uh, lab with, they can go for like other type of scanning also, like so the output will be differing for the same patient, right? So in that case, we can go for this vertical quantum assisted FL, where there will be local quantum embeddings um, forced at different clients. So here you can see, so institution A is laboratory running inside a hospital. So they'll be having the feature columns like taking blood tests, biomarkers, and genetics, etc. Kind of scans, ECG reports. So they'll have a different feature columns where they'll be running a local quantum feature encoder that produces the local quantum embeddings here, right? So this will be running parallelly with this institution B. So institution B is all about radiology. So here they are having like MRI scans, CT scans, and image metrics. So there are different feature columns here, and all these feature columns are running in their local quantum feature encoder, and they will be developing their own local quantum embeddings. Or for example, let me have this as A, and this will definitely be B. And in the institution C, like a pharmacy, they'll be having like drug history, dosage information, and prescriptions, etc. So this will be the different feature columns for this a particular institution. So all these are running into us in a same hospital, right? For a same patients in the same hospital, we have feature column A, feature column B, and feature column C. So all these feature columns will in turn give you its own respective quantum embeddings. For example, let it be like A, let it be B, and let it be C. So they will be passed to a secure channel, like passed to a federated server, which is a coordinator, through different secure channels. And for a same patient, we'll be like receiving different embeddings from institution A, institution B, and institution C. So we have like three different embeddings for the same patient, and all these three embeddings will be aligned and fused, and it will be passed to the quantum global classifier. And based on this classification, the patient is predicted with the outcomes, right? So this, for example, we are trying to find out whether the patient is having the risk of getting coronary disease or like heart attack. So we can have like multiple checks, like scan checks, and also pharmacy history of medicines already being taken by that patient. So you can have like multiple different embeddings that is being consolidated and represented in the future vector, and it will be given to the quantum enabled global classifier for prediction. So again, this will be fed to all the embeddings again, means all the institutions again, they'll be again doing the same thing again and again. So you'll be having different way of having multimodal. So this is what is called as multimodal. This quantum embeddings will have different representation based on these columns. This quantum embedding will have totally different representation based on this feature column. So everything will be differing from each other, but they are merged together, and it will be running on the federated server, right? So what are the advantages of having this? Like, um, So, with this way of segregating the institutions and creating the local quantum, you can have a, I mean, rich way of having or identifying the pattern. So, instead of having a single learning environment, when you have like multiple embeddings, this way of prediction, so this prediction will have higher accuracy than any other thing. Why? Because this prediction will find more complex data from all these institutions, right? So all the embeddings will give you a rich way of representing the data. So obviously, there will be identification of very complex patterns to find out this prediction rather than having a shallow way of predicting. But what are the challenges or what are the limitations of these of this architecture? So this architecture obviously increases the communication. Why? Because each institution will be communicating to the federated server for first passing on the model update and then receiving the global update. So obviously each of the institution, rather than having like one way of one-on-one communication of sending the model update and getting the model global model update, they'll they'll have in turn three different communications here. For example, here we have like three institutions. For three institutions, 3 into 2, 6 complexity of unit of communication complexity is imposed. But think of when you have like multiple institutions involved, then obviously it will create more communication cost. And also we need to have a proper maintenance of all these institutions, means like aligning of these institutions, right? In order to have a compatible or a compatible way of communicating with the server, right? So but the privacy is purely preserved. Why? Because only the embeddings will be shared here, not the feature columns, right? So obviously it will be giving more accuracy. So this is one set of research question where the quantum feature encoding will have like contrastive learning for medical AI, showing that vertical designs are becoming a concrete and promising research directions, like having these things like. But the question is all about how to maintain or how to have a trade-off on the communication cost with respect to getting the accuracy. So this is all about this pattern, which is like a very important pattern for having your research onto it. Then is probably the last pattern. No, this is sixth pattern, I guess. Like hierarchical edge cloud QPU. So this will be again a hierarchy where we have layers. So we have like edge clients and normally a coordinator, federated learning coordinator, followed by like model registry and all. So you can find here like more entities are involved, like model registries and also like aggregation, followed by like different execution layers. So the logic will be like edge clients like phone or whatever the things like edge devices, they'll be running the local data and training the local model, and it will be updating on to the privacy aware aggregation protocol. So it should be encrypted, right? So this edge will be encrypting the data, and it will be forwarding instead of directly communicating to the aggregator. Edge client will run this secure way of aggregating the data, and then the data, encrypted data, will be forwarded to the aggregator. This aggregator can be one level prior to that, which is like combination of phones. For example, I'm having a phone, I'm having a laptop, and I'm having a smartwatch. So all these are clubbed together and it will be formed as cluster A, right? So the data from all these, means the data from all these devices are clustered for one cluster, right? So aggregate the client updates for one cluster. Let me take it as C1. So this will give you like personalized output. So because all the data is purely relevant to me alone, so it will give you a high level of personalization, and also reducing the communication cost. Why? Because we are not directly giving this to the FL coordinator, rather we'll be doing all these things inside the local edge device itself, right? So then it moves on to the global model aggregation, and it will be versioned. Why? Because I need to have a registry which maintains what are the data I got from this phone, what are the data I got from this smartwatch, what are the data I got from this tab, what are the data I got from the CCTV camera, and what are the data I got from this Wi-Fi. So everything need to be properly back traced, so that I need to have a model registry that will be storing my version global uh, models, right? So there is a quantum execution layer. It will be running all the quantum hardware like circuits and quantum assisted optimization, kernel setting, clustering, and all, right? So this is not a simplified architecture. Rather, we have like a hierarchical way of representing, right? So, but this will be a proper, like highly scalable architecture. Why? Because the uh, amount of or the number of edge devices can be increased based on our requirement, right? It will not probably like affects scalability, I mean communication cost of the architecture. Why? Because they are communicating locally. So my phone and my smart watch will be communicating locally. I'm not using any cloud or uh, other things here. Any remote connections are not required, right? So the obviously it reduces the global communication, and also it will give you high level of personalization. Why? Because these things are all about storing my behavioral data. It is not about gathering something from the other person. So no divergence of having data here. So obviously it will be increasing the personalization. Also, um, the number of rounds will be getting reduced. Why? Because like quantum execution involves only reducing the cost and the queue time, right? Because I'm not anyways accessing the cloud which is in the remote connection. So because only one update will be done here. So every update will be done here only. Only like after doing multiple rounds, only single update will be done here. So obviously it will be reducing the communication cost. So this is all about your pattern, which is dealing with hierarchy between edge devices and cloud devices. So this will be kind of giving more more personalization rather than accuracy. If it is personalized, more personalized, then obviously it will be accurate also. Next is the last pattern, which is very important and like currently having like more number of research directions towards it. Decentralized and peer-to-peer QFL. So here it is differing from all the other patterns because here we'll not have any centralized way of coordinating, but we have clients which are having same level of authorization over the network. So there will be no central server, and each client will be updating or exchanging the model updates or model gradients through a peer-to-peer gossip way of communication or broadcasting, right? Kind of sending the message to everyone else in the same network, right? So you can see here there is no centralized mechanism here. There is no centralized mechanism here. Client A will be communicating with client B, client C, client D, and client E. So, which means one to all communication. And again, client D will also be communicating to all the other or rest of the other clients in the same network, right? So, it will be having like gossip way of communicating, and um, it actually works in such a way that each client will be training its local model. It can be of quantum assisted classical model, quantum assisted model or classical model. So it will be running their own data, and the local model will be updated there, and the clients will be exchanging the model updates with all of its neighbor using gossiping in a sense, like broadcasting it to every other client. Or there are other possibilities of having a distributed ledger here, like kind of blockchain. So you can have a distributed ledger here where this model A, you can have a distributed ledger here. So since it is a distributed ledger, it is shared by all the other clients. If model A is converging on, or if model A wants to update it, it will be updating here. And this will be known to all the others using this ledger. So this ledger will be known to B, C, D, and E. Once client A updates in this ledger, it will be known to all the others. And also, if client B try to update something, and it will be known to all the others, right? So it's a kind of uh, Google Docs. So you're sharing Google Docs with your friend, and you and your friend can also simultaneously edit that Google Docs, right? The same kind of working is in with this ledger. And if client B is updating something, client A can also view that, right? So all these things will be done here, and the say aggregation will be done uh, either in this ledger or within the clients itself. Like each client will be aggregating their own model updates with the other clients model updates, right? So there is no need for sending back to the clients from the server, or sending to the server from the client. So there is no way of like having this communication. But still, if you use a normal gossip protocol, then obviously client need to communicate with all the other clients, right? So this is a drawback, but still this peer-to-peer have its own advantages, because there is no single point of failure here. There is no workload here. Like there is, each client will have the same workload, so no one will be having like uh, extra workload, fine. And also the communication cost will be like possibly reducing, right? So there is the advantage of reducing the centralized coordination here, right? But still, um, this circuit will have its own limitations, because who will aggregate, who will securely aggregate, that is again a question mark, right? So who will coordinate if client E is disappearing? Who will do the work of client E? If client C is late, responding late, who will compensate this? So this is all the questions. So a more complicated way of convergence analysis, and communication complexity is also, if at all I'm not having this ledger, then what will happen? Client A will establish a communication with all the other clients. If the network has only 5 clients, then it will be like n minus 1 communication, which is 4 minus 1 connection establishment from client A. Now think of a network with 100. So for each model update, one client need to send 99 connection establishment and 99 transmission, right? Which in turn increase the complexity. So that they come up with the concepts like ledger, blockchain, smart contracts, and all here. So this is again open research problem where you can explore more, right? To reduce the message complexity or reduce the convergence messages and all, right? So this is all about the scalable architecture so far. So we have discussed 7 scalable architectures with different patterns, based on the communication, based on the point at which the quantum execution occurs, the point at which the responsibilities are divided among the client and server, the point at which the architecture is moving on from a single server oriented to peer to peer way of centralization, right? So this is all about the pattern, and then let me move on to the component architecture. So for a scalable system design, what are the components that need to be involved? So normally a quantum QAFL architecture need to have all these things. One is like federated orchestrator, because who will orchestrate or who will facilitate the communication? That is one question mark, right? And client runtime. So the client need to have a proper runtime execution to involve in the communication, and the architecture should have like quantum execution layer, model registry for denoting the model version. So we have like multiple versions involved. First we need to find out like who is giving the who is giving which model and what the model contributes to the overall accuracy. That question is still persisting, right? So that we need to have this model registry. Then the security layer for establishing a secure communication between the clients, and as well as the communication between the server and the client. And then we have like monitoring layer for saving the analytics, like details on how to incorporate the algorithms inside the core runtime components, right? So mainly we have this quantum execution layer. So the quantum, first we'll start with quantum execution layer. Why? Because that is the one who is having more responsibilities here, right? The quantum execution layer has the main responsibilities for hiding the backend differences behind the interface, right? They need to have the miscommunications or misconceptions, it should be like hidden, right? So, for example, if a client submits a circuit parameters and configuration and of all others, so this need to be executed by the quantum execution layer, and estimated gradient should be produced. For example, if if my circuits are running on more samples, the parameters and clients, it should be like optimized by the quantum execution layer, right? So it needs to decide on, like, instead of having the server overloaded to decide on the configuration, to decide on the number of runs, to decide on the maximum accuracy, to decide on the termination and all. So we are using this quantum execution layer. So this will be using its own things like quantum circuits to come up with the backend selection, like which simulator we need to use, come up with like which optimization you need to have, come up with like mm, executing in parallel clients, like which client need to given with which IID data, whether it is skewed non-IID, or which non-IID data I should have, like how come my data set should be precisely differentiated among the clients. All these things are taken care by this quantum execution layer. So the output will be like expected way of getting the gradients and the metadata, like what are the things we need to concentrate while on running the um, quantum, what is it, rounds, right? So also the logic will be something like this. FL orchestrator will be communicating or broadcasting its own configurations, like the client configurations and the training rounds and the initial model accuracy to the quantum execution layer, right? Parallelly, it will be assigning the work to the client also. The client will be sorry, client will be running locally in its own chief, like it will be running its own data and prepare the updates, right? So again, it will be forwarding it to the execution layer. So the execution layer in priorly get all the configuration data and the model running by the client, and it will be getting the current client's data, so it will be cross verifying it to find out the loss function. Also, this quantum execution layer will be forwarding the security, means like the necessity level of, or the expected level of security to the security layer, which in turn helps in secure communication, proper secure aggregation, and privacy preservation, right? So then this quantum execution layer simultaneously connects with model registry. The model registry will be storing the different versions of a model. So for example, let me have like 10 clients running on my system for almost some 72 rounds, for example. So on seven, at the end of 72 rounds, I'll be having a model update. That is fine. But how come I know this model has been updated from the contribution of this client? So that I can't know, right? So in that case, I can have this model registry on point, so that I can find out the versions of different models and parameters executed on that model, and the schema of the client, like whatever the schema of the client and the metadata on which it is running, right? So this model registry will store all these things, and we have a separate monitoring layer that will be taking care of the execution of this client, like the, not taking care, it will be like just viewing through the running or execution of the clients, followed by the alerts on if it is uh, prematurely converging kind of thing, right? So it will be just noting, kind of log, it will be noting down, and it will be updating it to the quantum execution layer, so that it will be uh, in the architecture in turn gets optimization throughout this work, right? So this is all about the components. Now what are the things, like what are the other way of having aggregation model, aggregation models at the server? So not at the server, in the peer-to-peer way of communication also. So first one is like federated averaging technique, which has already been discussed in the previous session itself. Next, let me move on to one more thing called fed prox. So which is widely used in this QAFL, which is Fed prox. Fed prox. So this type of algorithm will be separating the proximal terms. Means like the classical layers and the quantum layers may drift differently. That is obviously will have, right? So the quantum parameters may be more sensitive to noise and very short variance, but the classical layers will not turning up to that points, right? Sensitivity, right? So a stronger proximal term on the like learning parameter theta, on the learning parameter theta can stabilize the aggregation. So this is all about the context of fed prox. Then there are possibilities for noise to occur, right? So as we have already discussed, each clients will be having their own level of noise based on their quantum hardware, right? So in that case, we can have an option for clustering the clients. Clustering the clients. So, in what basis you can cluster the clients? So, clients can be clustered based on their data distribution. For example, an Apollo hospital, which is training on, which gives data based on elderly patients. So, there are other hospital like some other familiar hospital. Maybe they'll be giving some data on visibility, like eye related data, right? So the data based on this, you can group the institutions, like based on the distribution of the data, you can cluster the clients and also the hardware noise. For example, uh, there are client which is running on the hardware noise level of 10 to the power of 2, and some client is running on the same level or more or less the same level, then they can be clubbed together. So they can be clubbed together to have a clustered way of client, like. And also the very very basic way of clustering the clients would be like qubit counts. If the client is running the same number of qubits, or say more or less the same number of qubits, then they will be grouped together as the client. So each cluster will be maintaining a cluster model, and the global model can be formed based on the high level of aggregation between the models of these clustered clients. So this will avoid go for finding out the averages in case of your Fed average, right? So this will give you like some uh, way of approximation, not actually averaging, right? So then there are options for personalized quantum assisted federated learning, which I was explaining you in this model, not in this case. But no, this one. So here we have like uh, personalization pattern available, where you have shared quantum encoder, local classical head, and also like base model. So here also you can come up with like classic clustering. So clustering of this will increase the personalization in turn, right? So also you can have like in the model registry you have like meta learning stored. So you can, here the metadata is there now. So you can go for having a meta learning concept employed here. So this is all about the federated learning environment. So, what about the implementation? How come you can have the implementation for this? So, normally a federated learning environment, for the federated learning environment, people would go with flower framework. You all might know, right? Flower for research purpose, and it will give you the values or the purpose or then environment for setting up the FL experiments, right? And you can run federated algorithms in the TensorFlow. So this is what all can be done for implementation in the federated layer. So for quantum ML, you can have a, either like PyTorch, or um, you can go for using like penny lane also there, like penny lane. All these can be used for quantum ML layer. Other than that, there are packages like TensorFlow Quantum, and Qiskit also giving packages like QML for QNNs, and quantum backends are available in the IBM also. For the deployment, you can use Kubernetes to simulate at the small scale. So the cloud QPUs can also be accessed based on your number of runs like of an experiment. So this can be decided based on the nature of your project, and you can just set the ML flow. For example, if you want to have like secure way of aggregation, so if you want to use differential privacy, then you can go for implementing the what is that required packages also. But the constraints need to be considered here is one is like number of qubits. So number of qubits and the number of allowed gates, that you need to have a look on it when you try to implement it, right? And also the noise model, so it will also like create an impact on how to uh, configure your architecture, right? So the three things you need to understand is like first you need to check for the required number of qubits for your requirement. So based on that, you need to select the environmental setup or followed by the number of gates and the noise model, right? So normally you can start with finding out like the classical FL baseline, then you can go for simulating it in the QS. If you need, you can go for QPUs, which is running on the cloud, right? So this is all I would say for this architecture. Usually, what are the metrics you can infer from this? For example, machine learning will have like a accuracy as a metric, and we have like precision, recall, confusion matrix as a metrics, right? So in that case, what are the metrics of this QAFL? So it would be like accuracy, precision, recall, same as that of your machine learning. After that, you need to have one thing called communication cost. So, as I've already told you, federated learning will be one where the communication is involved from the clients to the server and server to the clients back and back, right? So, communication cost you need to know down. And one more thing is synchronization. So how come you're maintaining the synchronization between the clients and the server? That is again a question. For that, you need to come up with like you can first simulate in the virtual environment, like creating virtual machines and trying to communicate with the virtual machines. But obviously, the configuration would be of same that you need to check. Also the quantum metrics that you need to check apart from all these things, like normal quantum metrics are like number of qubits, depth of the circuit, and gradient variance, and the noise model, as I've already told you. So this is uh, all about the metrics. And also we need to come up with per client accuracy, like what is the accuracy posed by each client on each round, that you need to check, or otherwise a client will be running after its model convergence also taking the number of communication cost more, right? So if a model is converging at round number 40 and you are setting up the experiment till round number 99, then 99 minus 40 would be the extra communication cost, which is unnecessary, right? So you can go for checking out this earlier convergence also. So the things like the fairness metrics that needs to be taken care is one is per client accuracy, and the client which is performing best, that is also to be noted. Why? Because as I've already told you, if a worst performing client is not turning up for a long time, it which indicates that the client is crash gets crash fault, or otherwise if a node is behaving differently for 3 or 4 consecutive rounds, it means that there are possibilities for that client to be a byzantine node, right? So these are all the things that need to be taken care for each rounds. So this is all about this QAFL. Normally the applications of this QAFL is like fitting this environment for any privacy preserving uh, markets like hospitals, what is that, military, so radar, autonomous vehicles. So these are all the things that need to be considered for having this application, right? So again, every problems associated with federated learning, like IID data and non-IID data, everything will be persisting here. So that can be probably come up with terms like quantum split learning, quantum machine learning, and all. So these are all the things that is going out of the scope. So uh, with this I'm concluding now. So this session is open for the questions now. Do you have any other questions? And apart from this, one more research area is fault tolerance. So this has already been discussed in our previous session itself. So fault tolerance is like providing the same level of accuracy or same level of network contribution even amidst failures like crash failures and Byzantine failures, right? So this is one among the open challenges in quantum federated learning. Do you have any other queries? So if there is no other query, then we'll close the meet for now. Thank you. Thank you for the opportunity.
Uh, Thank you, ma'am. On behalf of our institution, I sincerely thank Dr. J. Chandrapriya, Department of CSE, National Institute of Technology, Tiruchirappalli, for delivering an insightful session on hybrid quantum classical federated learning models, algorithm, and integration strategies. Your valuable knowledge, expertise, and interactive presentation greatly benefited of all our participants. We truly appreciate your time and effort in making this session informative and engaging, ma'am. Thank you once again, madam.
Thank you very much, ma'am. I would like to thank the organizing committee for giving me this opportunity. Thank you. Thank you, participants, for lending your ears for the whole session from 9 to now. Thank you.
Thank you, ma'am. The participants are requested to go for the lunch and come back again at 1:30, and inform to please fill your feedback form without fail.
Good afternoon, Komal ma'am.
Hi, good afternoon. Am I audible, visible?
Yes, ma'am.
Great, thank
We'll
you.
start, ma'am. Yes. 1 second.
Sure, sure.
Let me introduce. Good afternoon to all the respected dignitaries, faculty members, and participants. We welcome you all for the next session on stress management, meditation, human values, and ethics. It's my great honor and privilege to introduce our esteemed resource person for today's session, Ms. Komal. Ms. Komal is a distinguished professional with a strong background in research, corporate training, and human development. She holds an MBA in finance and has over 15 years of experience in the areas of research and analysis. Throughout her professional journey, she has provided both primary and secondary research services for renowned organizations such as McKinsey and company NASCOM, SBI Life Insurance, and WNS Global Services. Apart from her corporate achievements, Ms. Komal has been passionately associated with the Art of Living Foundation for more than 17 years as an active volunteer and facilitator. She has also contributed significantly by organizing and conducting wellness and stress management programs for the Mumbai Police, including the Anti Terrorist Squad. She has facilitated corporate wellness and leadership programs for several leading organizations such as Adani Group, Barclays, Capgemini, Cognizant, Freshworks, Tata Communications, Wipro, and many others. In addition to her professional and training accomplishments, she is also a self trained artist who enjoys painting and listening to music, reflecting her creative and balanced personality. Today, we are truly fortunate to have such experienced and inspiring personality among us to guide us on managing stress, practicing meditation, and understanding the importance of human values and ethics in our daily lives. On behalf of everyone present here, I extend a warm and heartfelt welcome to Ms. Komal Ma'am. Now I request Ms. Komal to kindly take over the session and share her valuable insights. Over to you, ma'am.
Thank you. Thank you so much. Good afternoon, everyone. Can we turn our videos on? That way I know you're there, even if you're having your lunch. I'm hoping it's over. But if you are, give me a thumbs up. Let's turn our videos on so we can make this an interactive session. Yes? Yes. Good afternoon, Professor. So is this how usually the sessions are held every day, where everybody keeps the videos off? I'd like to know how this session is going to be conducted.
Yes, ma'am. Actually, they'll not open the video. The
Oh,
session goes on well.
okay. But then I don't even know if they're listening to me. Thank you for turning
I
your
may
video
ask
on.
them,
I'm
ma'am.
sorry, I didn't
Yes.
get your name.
Ma'am, this is Rajita Jasmine,
Hi.
Associate Professor, Naramk Engineering College, IT Department, ma'am.
Lovely, lovely. Great. So, in fact, this is where the topic becomes very relevant, that this is what ethics is, isn't it? If you think about it, that ethics is nothing but, doing what you want others to do to you, or not doing what others should not do to you. So as professors, I'm sure you all want your students to keep their videos on or listen to you if you're talking. Yeah, I'm sure you would also appreciate the same from us. So it would be nice, because this can be a nice interactive session, not one of those theoretical sessions where, you will just listen to a lecture on managing stress and not really know what to do about it. This is going to be a lovely session where we interact and get to understand how we can manage our stress. Yeah, so thank you for turning your video on. Would really appreciate it if some of the others can also keep their videos on. Yeah, will be really nice. So then we can start talking. Yes.
Participants, if possible, you can turn your video on and interact with ma'am.
That would
Okay,
be
thank
really
you.
nice. Thank you.
Ma'am, you may proceed, ma'am.
Okay, great.
You're sharing the screen?
No, I won't be sharing a screen. It's okay.
Okay.
I wanted to make this more an interactive session. I didn't want it to feel like a presentation. So I thought that it would be better if we do that. Yeah. So would be nice if we do have, even for some time, people can turn their videos on. Would be nice. Yeah. Okay, great. So everyone, hopefully you're there. Give me a thumbs up at least if you're listening, so I know you're there. Sub-region, okay, at least said good afternoon. Yes, from the others also would be nice if you could turn your videos on or give me a thumbs up. I know you're listening, even if you're having lunch, it's okay. Yes, thank you, sweetie. That's very sweet of you, sweetie Julia. Shobha has also given a thumbs up. Okay, nice. I'll wait for another minute, just in case you're off your desk or you're doing something else. No? Okay, fine. No problem. We get started. All right. So, everyone, I have a question to begin this session with you. Yeah. Have you thought about it that, humanity has achieved so much of progress in the last so many years? If you just think about it from the time COVID started or a little before that, technology has advanced so much. Communication has become so much better. We're working from home. We're doing sessions like this from home. The speed at which we travel, the speed at which we communicate, even data, information, access, everything has become so much better. There's so much more convenience. Right now, you can just order your vegetables at home, your fruits, everything comes home, whether it's your clothes, whatever shopping it is that you're doing, everything has become so much more convenient, isn't it? And yet, at a time like this, you see that people are still struggling, whether it is with stress, anxiety, loneliness, emotional fatigue, anger, burnout, isn't it? It makes us think that if the outer world has advanced so much, should the inner world not have also advanced the same? Yet, we feel that inside there is so much of disturbance, isn't it? It brings us to an important question, that can outer success truly be meaningful without inner well-being? Gurudev Shishi Ravi Shankarji, our founder, he says that we've learned to fly like birds and swim like fish, yet we've not learned the simple art of living together as human beings. So just this one line captures how we all are, isn't it? Or how we all feel. Because you think about it, this is the challenge of modern life. There is success in the outer world, there is speed, there is so much over there. People know how to achieve, yet they don't know how to relax. We know how to compete, but we don't know how to connect. We know how to accumulate information. You have AI that does so much for you, yet you don't know how to use the same wisely, isn't it? So, conversations around stress management, ethics, human values, they're not really optional anymore, they're essential. So, what I'd like to begin is, I'd like us to understand what is stress. So, here's a question for you. Use the chat box if you don't want to turn your video on. If you can turn your audio on and speak also, will be great. What, according to you, is stress? Any responses? Yes, Dr. Sarvanan. Hi.
Very good afternoon, ma'am.
Good afternoon, sir. Yes, sir. My question is, what is stress? How do you define stress?
Now we are conducting an event. This itself is a stress, ma'am.
Conducting this event itself is stressful. Why do you feel that way? I'm happy that you're sharing a very honest answer. Yes.
So I have to make the participants to join on time, resource person on time. All this there.
Yes. So this is mental stress for you. right?
Yes, yes,
Because you feel that what you have to do has to be done on time and has to be executed correctly. And if that doesn't happen, that causes stress.
yes,
Correct?
yes,
Okay, great. Very nice. Then we have another response here again, where professor is saying that it is because of pressure or tension. Yeah. So if you think about it, when we speak about stress, it's not what you have to do that causes stress, but that ability to do it in that given period of time with your limited energy causes stress. If there's a wedding in the family, you may say it's stressful, yet it's very joyful, isn't it? Because there is stress, but there is so much of happiness attached to it, and you don't mind the pressure. You say, okay, I will not sleep for 2 nights, but I will get this done, isn't it? There is so much of joy, right? So if you think about it, stress achieves results. But when you feel that you're unable to do it, when you feel that there is a restraint on your time or on your energy, that is what causes stress, isn't it? Yeah. So I want us to understand what is stress even better. There are three sources of stress, major sources. If you think about it, first is at a physical level. Yeah, like Dr. Sarvanan is saying that to achieve things on time. So I'm sure, sir, what would have been happening is there is probably disturbed sleep right now because I have to get work done. I have to achieve things in that limited time, right? So one of the major sources of stress for all of us is, the inability to sleep on time. Second is our lifestyle, because we're sitting in front of our laptops or standing in classrooms or conducting our sessions, however we're doing. We don't even have time to eat on time. We don't sleep on time. We don't really have time to exercise. And if we have it also, we're just so tired all the time, right? You feel so low on energy. So, physical stress is due to lack of sleep, poor lifestyle, constant stimulation of the mind. Yeah. And then what all of you are going through probably is overwork, which most of us in today's age feel that it's a given. So many of the youngsters these days want to leave the country because they say, abroad when you go, at least people respect your personal life. In India, we take it for granted. Yeah. So, what is important is that we realize that personal stress is what we all go through physically. Yeah. So, because of overstimulation of the mind, overworking, because of lack of sleep, and most importantly, because of a poor lifestyle. The second source of our stress is mental stress. And this is something we're unable to define really. If you think about it, you're thinking too much. So, overthinking is a cause of stress. Then, your expectations, you expect somebody to do something for you, you expect certain things to go a certain way, but they don't. That causes stress. Yes. The third source of mental stress is this constant comparison. Why is he getting that? Why is she getting that? Why am I not where everybody else is? As a result, you have negativity, you have jealousy, all of this creeps up. And the fourth is lack of clarity. You sit down to do something, but your mind is just all over the place. Do you agree? Yeah. So these are the causes of mental stress. For emotional stress, you feel hurt about something. Yeah, you feel that you've gotten into a conflict with your faculty members, with somebody at home, or with a friend or so-called friend, right? Then because it becomes a conflict, if you notice when you start feeling hurt, you start secluding yourself. You don't want to be with people, right? As a result, you also start suppressing your emotions. You start feeling lonely. Do you agree? Yeah. So these are the three major sources of stress if we had to define them: physical, mental, and emotional stress. Are you with me, everybody? Give me a thumbs up if you're listening. Okay. So I want us to then understand that when we are speaking about stress, if you've noticed, we define stress saying that it is limited time and limited energy. That is the cause of stress. Tell me, everybody, can you increase the number of hours that you have in a day to work? Whether you're the president of the country, the prime minister, or you're the peon in the office. Yeah. wherever, whatever levels we are at our workplace or in our personal lives, we all have only 24 hours to work. Yet the Prime Minister and the President get more out of their day as compared to some of us. Isn't it? Of course, you'll say they have more resources and all they have to do is get their work done. But that also requires a lot of energy, right? So I want you to just recognize that, see, time is limited for all of us, but energy can be increased. Do you agree with me? Observe when your energy levels are high. Have you noticed you feel very happy? You feel very positive. You feel good, isn't it? When your energy levels are low, you realize that you feel very tired easily. You feel kind of depressed. You're burnt out, fatigued. All of this is nothing but because of low energy, right? So if you could increase the energy that you have in the day, you could increase the state of your happiness also, the state of your mind. Haven't you noticed when you're high on energy, you say any problem that comes, chalo, we'll take care of it. Yeah, we'll do it. Isn't it? On the other hand, when you're low on energy, have you thought about it? See, when your phone is low on charge, what do? You go ahead and charge the phone, right? You say it needs more battery power. But when you are low on charge, when you are low on energy, what do? You continue to function just the way you have to, isn't it? As a result, your relationships suffer, your work suffers, you start having low self esteem because you start making more and more mistakes. You feel down, you feel depressed. So, what we need to learn to do is pause and recharge, isn't it? Recharge ourselves. So, I'd like to understand from you that where do we get energy from? If you could share in the chat box or unmute yourself, what are your sources of energy? Where are you getting energy from? I'm sure you're all having that energy source in your hands or in your mouth right now. One of the major sources of energy for most of us would be food, isn't it? Yeah. So there are four major sources of energy. First is food. Second is sleep. So along with food would be your sunlight, your air, oxygen, everything that you are looking at the environment. We'll come and put all of this into these four categories. Food, water, along with it, nutrition, whatever you say. Sleep would be the second source of energy. Yeah, rest, which is important more than just sleep, right? The third would be the state of your mind. And the fourth is the breath. I'm going to just explain each of these a little bit so we get an understanding of how we can increase our energy levels and thereby reduce our stress. So, food, would you agree, is a major source of energy for all of us? I'm sure if you're not fasting today, you're having your lunch or you finished your lunch, your energy levels are relatively high, isn't it? Yeah. If you just think about it, on a day when you're fasting or you haven't eaten anything, you haven't had your breakfast, you haven't had your lunch, have you noticed the state of your mind? Very easily irritable, isn't it? Yeah. So if you're not eating, you feel irritated, you feel tired, you make, there's this new term for it, in fact, which is called being hangry. You're hungry and therefore you get angry, and therefore it's called being hangry, isn't it? If you think about it, when you overeat, you go for a wedding, you go at every counter that is there these days. You have the pasta counter, the dosa counter, the pizza counter, and then not to forget the desserts. You eat at every counter that is there, and then somebody tells you, come and take a class or do some work. What do you say? Oh my God, I want to sleep. I've eaten so much. Isn't it? So if you just think about it, when you're eating food, it's only when you have food in the right quantity and the right quality that it gives you energy. It is said that this is the size of our stomach. Yeah. If you remember, we learned it in biology. this much food to eat is sufficient. Now we live in South India. We heap up our rice. I come from Maharashtra and Gujarat. We don't believe in putting our hands together. We eat as much as we want, not as much as we need. Isn't it? So it is said that the right quantity of food and the right quality of food gives you energy. The American Medical Association says that having 5 helpings, in a day of fresh fruits, green leafy vegetables, seeds, nuts, eating more vegetarian food is more conducive for our health. Yeah. You compare this with eating too much of food. If you think about it in the Ayurvedic way, food is quantified in 3 different categories. There is sattvic food, rajasic food, and tamasic food. Tamasic food is food that we have cooked in the morning and you're eating late in the evening. Canned food, food that was prepared much earlier, non-vegetarian food. All this food will fill your stomach, but in terms of prana or energy, nutrition it may give you, but in terms of energy, it doesn't give you anything. Yeah. So that is tamasic food. Canned foods also come into that. Ready to cook meals, all of this will come under this category. Then you have Rajasic food. Rajasic food is food which you eat and where you feel that, it's really delicious, very sweet, very oily, very spicy, the tasty masaledar food that we call, which may be great to eat, but you need to channelize the energy that's created with this kind of food. That's why it's called Rajsik, the food that the Rajas or the kings used to eat, which would be really a big meal. But if you don't channelize the energy after meals like this, you will find yourself feeling very lazy. You'll find yourself feeling very lethargic or even restless. Yeah. You're sitting there, somebody is talking to you, but you're sitting with your phone and you're constantly going ahead and playing with the pen. You're doing this, you're going ahead, shaking your hand or your leg, or your mind is going all over the place. You're not really there. This is when you're eating a lot of this kind of food, which is called Rajasic food. Creates restlessness when the energy generated from this food is not channelized. Yeah. If you're eating sattvic food, you have a fresh bowl of fruits, green leafy vegetables, salads, seeds, nuts. Just observe the moment you have something like this, which is fresh, light, and just, maybe cooked food also, but lightly cooked food, not overly cooked food. You see that it gives you that energy, which makes you feel uplifted. Yeah, this is sattvic food. So food is a major source of energy, and we all usually go ahead and every time you're low on energy, you'll go have a cup of tea, coffee, or you'll eat something. Observe what it is that you're having. Yeah, tea and coffee give you caffeine kicks, but they also create acidity in the system. If you're sensitive, you'll notice that it makes you feel uncomfortable, makes you feel very restless. You don't even feel good after it. Yeah, it may be just giving you that instant kick for a few moments, but after that, the drop in energy is quite drastic, which is why people like sipping their hot teas and coffees all through the day. And it's not really great for our systems. Yeah. So observe what kind of food we eat. The better, if you want to be higher on energy, having more fruits, more green leafy vegetables, seeds, nuts, salads, all this, make that at least 50% of your meal and see the change in your energy levels. Yeah. So this is not a session where we just want to keep on talking. We want you to also have these takeaways that can help you to manage your stress. Yeah. So the first thing that we need to do is pay attention to our food if we want to increase our energy levels. Quantity and quality both. Yeah. Remember, this much food is sufficient. So if you're eating a lot of carbs again, you will feel low, you will feel tired easily. Carbs and protein both is a great mixture, and that's something that's part of our meals. We eat rice with sambar, we eat idli with sambar, dosa with sambar. Make sure that you have your proteins. The vegetarian proteins are good enough. You don't really need to go into the non-vegetarian ones, but that's your choice. Yeah. So food is one source of energy. Sleep is the second source of energy. Very important. If you just think about it, how many hours of sleep do we all need? 6, 7, 8, isn't it? When you end up sleeping more than this, if you've had that luxury of going on a holiday or a vacation, which I'm sure many of you must be looking forward to doing soon, and you're able to sleep for 12 hours, or if you sleep even longer, have you noticed how you feel after that? You're usually very dull, very lazy, you feel very lethargic. Somebody tells you, Chalo, let's work, and you're like, Arey, not now, baad mein, after some time, aprama, not now. Let me have some coffee, let me eat something, give me some time. No? So, if you've had too much of sleep, you feel lazy, you feel lethargic. If you've had none of it or less, you notice you can't focus the next day. You're very irritable. You feel that, array, my brain, I have brain fog these days, we say. My head is not working, my brain is not functioning because you're not getting good rest when you sleep. Yeah. So, again, in sleep, if you have too many dreams, you don't wake up feeling very fresh. Many of us go through that these days. So, it's very important that we're able to get good rest when we sleep. Yeah. And I would like to take you through a session where I can get you to rest also. Yeah. Where you understand how you can do this, where you lie down and take the next of the session. If you would like to, we could do that. Otherwise, we can go through a meditation also, which is very good way of resting. So, second is sleep. The third source of energy that we all need to pay attention to is the state of our mind. Have you noticed how important it is? Monday morning, somebody comes early morning and starts complaining to you, or your maid comes and she's like, "Oh, this is happening." Somebody in your house starts complaining, or your colleagues come and start giving you negative stuff. How do you feel? Like, "Arey, don't get started early morning," isn't it? We all want to say, "Please, don't do all this early morning. We'll speak later on." Why? Because you realize that it reduces your state of happiness. It reduces your energy levels. If you're going through too much of worry, if you're going through anxiety, you're feeling tired, you wake up only not feeling good, you realize the state of your mind impacts your energy. Work that could take 1 hour, you take 3 hours to do. Your mind is just going all over the place, isn't it? We'll come to understanding this mind also. Yeah, but this is the third source of energy. When your mind is feeling happy, you listen to good music, you go to the temple, you do some chanting, you do some prayers, you meditate, you listen to a good speaker, you read something nice, you go for a walk. Yeah, you're in the company of good people, positive people, you feel very good, isn't it? So, this increases your energy. Yeah. The fourth source of our energy is the breath. Probably something most of us haven't paid attention to also. Think about it. What was our first act in life? To breathe in and then cry. Yeah. And what will be the last act in our life? To breathe out and then hopefully make the others cry. If you led a good life, isn't it? If you didn't lead a good life, they're going to say thank you, goodbye, bye bye. Yeah, isn't it? Just think about it. All our life we keep breathing, but we hardly pay attention to the breath, isn't it? It is said that 80 to 90% of the toxins can get thrown out of our system if we breathe correctly. And the average human being utilizes only 30% of their lung capacity. Isn't that amazing? We don't even breathe fully. Yeah. If we could just breathe fully, it could change the state of our mind. There is a link between the breath and our emotions. This is something I'd like you all to answer. I want to ask all of you, and please use your chat box if you don't want to unmute. How is your breathing rhythm when you are angry? I'm sure we all go through this emotion. How do you breathe when you're angry? No response. Forcefully, Kanmani says, okay, Kanmani, yes, thank you. It's forceful. Have you noticed? It's also very fast, isn't it? Yeah. It's also very shallow. Yeah. Same time when you're upset, have you noticed how your breath is? Very heavy. Haven't you seen this? Yeah, you feel that it's difficult to breathe. When you're tired, you come home, what do? You go plonk on your sofa and your exhalation is so long. Like, have you seen this? When you're carrying something, you need some energy, you're carrying something heavy. What do? You take a deep breath in and then after you can't hold it anymore, you'll breathe out and so just observe, yeah. Whatever actions we are doing, whatever emotions we are doing, they're reflected in the rhythm of our breath. In fact, every incoming breath energizes our body, and every outgoing breath relaxes it. We hardly pay attention to the breath. Whatever emotions we're going through, when it's anger, your breathing is very fast, very shallow. Yeah. When you're upset, it's heavy, it's slow. Have you noticed? When you're nervous, it's a different kind of fast. It's very shallow and, it's quivering. Your breath is not even normal, right? So whatever emotions are going through our mind, they are reflected in the rhythm of our breath. So if you change the way you breathe, you can change the way you feel. And that is the key of managing the mind. If you think about it, nowhere in school or college did we learn how to breathe or to manage the mind, isn't it? I hope now we're teaching that in some colleges at least. I know it is there. But did we learn it when we went to school, college? Think about it. We learned so much about history, geography, science, maths. All of you here are teaching so many more topics and you've learned so much. But did you learn anywhere how to manage the mind? The quality of our life depends on the state of our mind. Wouldn't you agree? If your mind is happy, you're feeling positive, you're feeling good, you're on top of the world. But you could literally be on top of the world. You could be in the best place in the world. And if you've had a fight with your loved one, or if you're upset about something that has gone wrong, does it matter where you are, how much wealth you have, what you have been served to eat? No, isn't it? So it goes to show us that the quality of our life depends on the state of our mind. And stress gets in the way, right? So I want us to now understand. Yeah, we're going just from understanding what is stress. Those of you who joined in a little later, yeah, we define stress as something that we have to do. Yeah. And yet, whenever you have to do something, you feel that you have limited time and limited energy. That is the cause of stress in our lives. Time, you can't do anything about. You can't go back and keep asking for more time. You can't ask your deadlines to be extended. You can't do anything about the limited time that you have. But your energy is in your hand. And which is why we are speaking about the 4 major sources of energy: food, sleep, the state of our mind, and the breath. Food and sleep are 2 sources of energy that can only be optimized, which means only up to a certain level will they give you energy. As we spoke about it, discussed, that when you exceed it, your energy levels actually drop. If you sleep too much, you're not energetic. You eat too much, you're not energetic. You eat or sleep too little, also you're low on energy. Yeah. So very important that the right quantity of food, the right quality of food, and good rest in your sleep gives you energy. But the more attention you pay to the state of your mind, to your breath, you can feel more and more energetic, more high on prana, as we call it, or subtle life force energy. Yeah? In the Chinese culture, in the Eastern Asian culture, it's also called chi. Yeah. So it is nothing but energy. Good so far, everyone? Yes? So 4 major sources of energy. And if you're able to pay attention to these, you're able to increase your level of energy. Thank you for giving me a thumbs up, Kanmani. I know at least you're listening. Yeah. So these are the 4 major sources. Now, let's understand the mind a little more. You know what causes stress is not just this limited energy and time. I'm giving you another definition of stress. It is the constant vacillation of the mind, this constant thought, movement that is there in the mind that causes stress. I'd like you all to do an activity. Just close your eyes for a moment, maybe for half a minute, and just observe what's happening to your mind. Close your eyes. Observe if you have thoughts that are coming to your mind. What are these thoughts that are coming about? Are they thoughts about the past? Thoughts about the future? If they're thoughts about the past, I want you to put them in a box. Pretend there is a box to your left. I want you to put them all to your left. If they're thoughts about the future, then put them to your right. Slowly, you may open your eyes. How many of us realize we have so many thoughts about the past? Me a thumbs up. Thoughts about the future? Yes, thank you, Kanmani. Yes, sweetie. Yeah. So you see, the mind is constantly doing this, and this constant vacillation of the mind, like a pendulum, going from the past to the future, is the cause of stress in our lives. Do you agree? See, when your mind goes into the past, what are the emotions that come up? One, it could be nostalgia. You go ahead and say, oh, life was so much better when we went to school or college in our younger days, or we hear our parents say that. Yeah, so you make life much larger than it is. You make the good times even better than they really were. That's fine, yeah. Or you go through these negative emotions where you go ahead and feel because something didn't go right, you go through regret. You go ahead, then become sad because of that. As a result of that sadness fermenting more and more, you get angry easily. Think about it. Yeah. These are the emotions affiliated to our past. When your mind goes into the future, if it's positive, you're excited about something that's going to happen. But that excitement stays for some time, and then the mind starts going into the negative emotions again. Oh, but what if things don't go as per my plans? Then there is fear, there is anxiety, there is worry, isn't it? Think about it. Where is life going on? Is it in the past? Future? No, it's in the present, isn't it? So it's this constant vacillation of the mind between the past and the future that is causing stress in our lives. And one of the first things that we teach on our Art of Living program is to live in the present. But have you thought about it? That when you tell your mind to be in the present, doesn't really listen. Isn't it pretty much like our students that we have in class who don't listen to us? Or like children, yeah, younger children. Have you noticed you go and tell them, don't put your finger in that electric socket? They'll go running there only, Mama, Papa, here. Isn't it? The moment you tell your mind not to do something, it does exactly that. Let's observe this. Close your eyes again for a moment. Yeah, just for a moment and think about whatever you want to, but don't think about a monkey. There's a monkey on the screen with a red cap on, wearing a white t-shirt, carrying a haversack. And if you had your eyes closed, open them. We could all see the monkey, isn't it? Just observe. Yeah. The moment you tell your mind not to do something, does exactly that. Yeah. So the key to managing the mind is not from the level of the mind, but it is with the breath. And that's what I'd like you to all experience. Yeah, we were talking about managing stress. So here is the key to handling the stress, handling this mind which causes stress. Yeah, the key is the breath. The first act in our life was to breathe in. Last act in our life will be to breathe out. All our life we keep breathing, but we hardly pay attention to the breath, isn't it? So here we're going to just first observe how we breathe. So I'd like all of you to sit straight, yeah, with your spine erect, and place one palm on your chest, the center of your chest, one palm on the stomach, the lower region of your belly. Yeah, and close your eyes and just observe how you're breathing first. So just close your eyes and keep breathing. So as you breathe, I want you to observe one, is the body expanding as you're breathing in, or is it contracting when you're breathing out? Is it the opposite? When you're breathing in, is your body contracting? And when you're breathing out, it is expanding. So observe what is happening. Second, I want you to observe, where are you feeling the movement? Is it only in the chest region or the abdominal region or both? Yeah. Slowly relax your hands and open your eyes. You can use the chat box and let me know what did you observe, or you can unmute yourself. Where was the movement when you were breathing in and breathing out? No responses? Okay. So if you were breathing correctly, you would have felt that when you're breathing in, like you blow air into a balloon, the body expands. When you're breathing out, it contracts. Isn't it? We learned this in science and you've seen this practically. But for many of us, it may not be happening. And it's okay. Yeah, don't have to punish yourself for it. The moment you realize that you're not breathing correctly, you simply do that. Yeah. So you go ahead and push your belly out as you breathe in, and slowly, slowly you bring it close to your spine as you breathe out. Yeah. So let's do that. Let's just experience this for a few moments where we consciously take our mind to be with the breath and we breathe correctly. Yeah. It's called yogic breathing. Yeah. Place one hand in the center of your chest, one in the center of your tummy. Yeah. And close your eyes. And as you breathe in, blow. It's like slowly somebody's blowing air into your lungs and you feel your abdominal region is expanding. And so is your chest, all the way up to your shoulders, the clavicular region. And slowly, slowly as you breathe out, feel like your navel is going to go touch the spine. So slowly breathe in, push your belly out. Let your lungs fill up the chest. Feel the movement all the way up to your shoulders. Keep breathing. And slowly, slowly breathe out till you feel that your navel is close to the spine. Breathe in, push your belly out, fill your lungs, feel the chest go up, expand all the way up to your shoulders, the clavicular region. And slowly, slowly breathe out. Breathe out where you feel that your belly is coming close to the spine. Breathe in, push your stomach out, fill your lungs, feel the chest expanding all the way up to the upper chest, the shoulders, the neck, the clavicular region. And slowly, slowly breathe out where you feel the navel coming close to the spine. Let's continue another 4 or 5 times on our own. Breathe in. And breathe out. Breathe in. And breathe out. Continue. Breathe in. And breathe out. 2 more times. Breathe in fully. Let your stomach expand. Let your lungs expand, the chest region, all the way up to your shoulders. And slowly, slowly breathe out. Breathe out where you feel your belly coming close to the spine. One last time. Breathe in. And breathe out. And keeping the eyes closed, just relax your hands and observe how you're feeling. Breathe in and breathe out. A deeper breath in and breathe out completely. And slowly, whenever you feel complete, you may open your eyes. How's the mind feeling? Let's hear from you. Use the chat box. You can give me a thumbs up if your mind is feeling calm. Thumb down if you're feeling agitated. How's the mind? Karamani is feeling good. Nice to hear that. Julia, what about you? Sarvanan? Anybody else would like to share? Nice. So if you see, the moment you take your mind to be with the breath, the mind starts calming down, starts relaxing. Yeah? It's like if you want to fly a kite, yeah, you need to have a long string. Only then will that kite fly. You know, many times we give a kite to children to play and we don't give them a long string. What do? They just keep dragging it down behind them. It's just like a little toy that's following them, isn't it? Similarly, if you want that mind which is flying like a kite all over the place, if you want to have control over it, you use the breath. Yeah. because to control that mind from the level of the mind is difficult. Using the breath, which means the longer, the deeper your breath is, the calmer your mind becomes. Yeah. So this is the key to managing your mind, the breath. Are you all with me? I hope you're listening. Yes. So what I'd like you to do is learn a breathing technique that can instantly calm the mind. Yeah. And then we'll do a little bit of a meditation. So if that's a good idea, it would be nice if you keep your videos on. We're going to learn a breathing technique which is called the Nadi Shodhan Pranayam, or the alternate nostril breathing. Can be done by everyone. You can look up the scientific benefits of doing this. I'll just give you an experience of the same. Yeah. So what you do is you sit with your spine erect. Every time you're doing any breathing technique, it's essential that the spine is erect, because that is like the highway, yeah, where your breath is flowing through. So we need to keep that straight, erect, and preferably no back support for the 5-10 minutes when we do this breath work. Yeah. So this alternate nostril breathing is also called a pranayam. Yeah, it's called Nadi Shodhan Pranayam. And prana is what we spoke about, energy. Yeah, subtle life force energy. Ayam is giving direction to this energy. So what we're going to do is learn this breathing technique, which instantly relaxes the mind, calms it. It opens up, we have energy centers in the body. It opens those up as well, makes you feel very relaxed and calm. So what we do is we begin by using the left hand in something called the chin mudra. Yeah, so I hope the session is going good. Even if it's not, you're going to fake it. So you go ahead and do this. Yeah, you go ahead and say, oh, excellent, like this. So I want you to make a perfect circle using your thumb and index finger gently touching. Yeah. And your 3 fingers are straight. Okay. Turn this around and place it on your left knee. This is called the chin mudra. You use the right hand. If you're wearing glasses, you may remove them. You use your index finger, middle finger, you place it between your 2 eyebrows, and you breathe in from both the nostrils first. Lock the right nostril with your thumb and breathe out from the left. Now you breathe in from the left nostril. Lock it with the ring finger. Release the thumb. Breathe out from the right. Breathe in from the right nostril. Block it with your thumb. Breathe out from the left. Release the ring finger. This is one round. So you breathe in from one nostril, breathe out from the other. Breathe in from this nostril, breathe out from the other. Yeah. So we'll do 9 such rounds of alternate nostril breathing. Breathe slowly, make the breath long and deep, and let's see how you feel with that. Yeah. Then I will guide you through a meditation also. So left hand in chin mudra, thumb and index finger in a perfect circle, 3 fingers together. Index finger, middle finger between your eyebrows, spine erect. Breathe in from both the nostrils. Block the right nostril with your thumb. Breathe out from the left. Breathe in from left nostril. Block it with your ring finger. Release the thumb. Breathe out from the right. Breathe in from right nostril. Block it with your thumb. Breathe out from the left. Release the ring finger. Breathe in from left nostril. Lock it with your ring finger. Release the thumb. Breathe out from the right. Breathe in from right nostril. Lock it with the thumb. Breathe out from the left. Breathe in from left. Lock it with the ring finger. Release the thumb. Breathe out from the right. Breathe in from right. Lock it with the thumb. Breathe out from the left. Breathe in from left. Lock it with the ring finger. Release the thumb. Breathe out from the right. Breathe in from right. Lock it with the thumb. Breathe out from the left. Continue. Breathe in from left. Breathe out from the right. Breathe in from right. Breathe out from the left. Continue on your own for another 4 more rounds like this. Keep breathing. Make the breath longer and deeper. And as you breathe out from your left nostril, you may relax your hands and keep the eyes closed. Keep the palms open, facing the ceiling. And just observe the state of your mind. Observe the rhythm of your breath. Take a deep breath in. Breathe out. A deeper breath in. And breathe out completely. And slowly, whenever you feel complete, you may open your eyes. How are we feeling? How many of us feel that the mind is becoming calm and quiet? The breath is becoming longer, deeper. Yes, you can give me a thumbs up if you're feeling that. Okay. So what I'd like us to go through now is a meditation. Yeah, because remember we were sharing that to manage the mind from the level of the mind is difficult, using the breath is easier. So if the mind has calmed down, we relax it even further by meditating. I will say, what is meditation? Many of us would think meditation means concentration, focus on the breath, on the mind, on some point in the head. Yeah. But actually, it is the opposite of concentration. It is deconcentration. Meditation is the process of doing nothing at all. So where we think that we have to focus, we have to do something, you actually have to let go. Yeah. Just think about it. The moment you tell your child not to do something, they do that. Similarly, if you tell your mind not to think about something, it will. Yeah? Which is why you allow the mind to just relax. It's like when you're listening to music. How do you listen to music? You just go ahead and listen to it, isn't it? You're not focusing now the guitar is playing, now the tabla is playing, this is playing, that is playing, the synthesizers are being used, unless you're sitting to analyze. But if you're just enjoying the music, you're just letting go, you're just being with it. Yeah. Similarly, here, I will give you instructions. You simply take your attention to whatever is being spoken. If your mind goes away for a coffee break, gently bring it back and listen to whatever is being spoken. Is that okay? Yes? So, staying seated where you are, preferably sit comfortably and easily. If you want to sit with your legs crossed, if you want back support, feel free to do that. Close your eyes, keep your palms open, facing the ceiling, because it makes the breath longer, deeper, easier to breathe, yeah, as compared to keeping the palms turned downward. Yeah. So we do that and just close your eyes and follow the instructions. So I will tell you to take your attention to different parts of the body. Whatever I say, you just have to listen to it. So example, I tell you take your attention to your right foot, right knee. You don't have to shake it, you don't have to do anything. You simply be with whatever instructions are being given. If you think you're falling asleep, it's okay. Anyways, you have your video off. Just don't lie down. Don't be horizontal. You do this entire process sitting straight. And once we're done with this, I'll share with you what is the difference between meditation and sleep. Yeah. So keep your eyes closed and we'll get ready to take off. So sit comfortably and easily with your eyes closed. And take a deep breath in. Breathe out. A deeper breath in. And breathe out completely. Become aware of all the sounds in the environment. Whatever sounds that you can hear. Maybe the sound of your fans or air conditioners, people working around your rooms, maybe outside your house, some faint honking or traffic sound. Whatever sounds you hear, whether it's a sound of a dog barking or maybe some birds chirping, just accept them. The moment you accept these sounds, they go into the background. Be in harmony with all the sounds in the environment. Take a deep breath in, breathe out. Become aware of your body. The body is a beautiful gift given to you by nature. Let's honor and respect this body very dearly. Take your attention to your right foot, right knee, right thigh, right hip, take your attention to the whole of your right leg. Left foot, left knee, left thigh, left hip, take your attention to the whole of your left leg. Genitals, stomach and abdomen, navel region, chest, right arm, left arm, shoulders, neck, face, head, take your attention to the whole body. Take a deep breath in, breathe out, a deeper breath in, and breathe out completely. Become aware of your thoughts, whether they're good thoughts or bad thoughts. Do not resist them. Be in harmony with your thoughts. Breathe in and breathe out. Be in harmony with your thoughts. Take a deep breath in, breathe out. Become aware of your feelings. Do not resist them. Be in harmony with your feelings. You are peace. You are joy. You are peace. You are joy. Become aware of your feelings. Become aware of your thoughts. Become aware of the sensations going through the body. Become aware of all the sounds in the environment. Take a deep breath in. Breathe out. A deeper breath in. And breathe out completely. And slowly, as and when you feel complete, you may open your eyes. You can use the chat box to share how you're feeling, or give a thumbs up if you're feeling quiet and calm and fresh, relaxed, energized, any of these words, or anything else. Well, looks like no one's there. I don't know if you are. It was a 15-minute meditation. I hope you're feeling good. Wanted you to get an experience of that. Yeah. So, meditation and sleep, there is a difference between the two. If you feel that, oh, I went off to sleep, in your sleep, you won't hear anybody say, take a deep breath in, breathe out. Nothing you will hear, right? But in meditation, you do, because meditation is deep rest, deeper than your sleep also, and yet there is awareness. In sleep, there is no awareness, there is just rest. It is said that 20 minutes of meditation can give you rest, which is equivalent to 4 to 6 hours of sleep. So if you're somebody who's falling short of sleep every day, the moment you start meditating, you will find that your sleep gets better and the mind gets deep rest. So in fact, scientific research also says that the gray matter in our brain also improves. Thank you, Dev Kumar. Yeah, so happy to hear that somebody else is also listening. Yeah. So just wanted you to get this experience of meditation. If you would like to, we also have programs where we teach how to meditate. So you can do that as well. The key to meditation, like we said, is just the art of doing nothing at all. Yeah. So just relaxing. So wanted you to get an experience of that. So like we started the session talking about managing stress. He said there are 4 sources of energy, because we define stress as something that gives us stress because we have too many things to do and too little time or too little energy. Given that we don't have control over the time and the things that need to be done, we definitely can control our energy. And which is why we said that there are 4 sources of energy. Yeah, food, sleep, breath, and the state of our mind. Relaxing the mind comes under the state of mind also, because meditation gives us a lot of energy. So does the breath. Wanted you to get an experience of that. And now, before we conclude the session, we also wanted to speak. In fact, that was one of the topics that we were going to share, is speaking about ethics. And I started the session when a few of you were here saying that ethics, our founder Gurudev Shishi Ravi Shankarji says, is something that comes to us naturally. Yeah, ethics is expecting someone to do what you want to do to them, right? Or not doing what you don't want somebody to do to you. For example, if you're in a relationship, you don't want the other person to cheat on you, is ethics, and therefore you don't cheat on the other person also. If you're an employer, you expect your employees to be honest with you and not cheat on you. Expecting the same out of your employer is maintaining ethics. Yeah. So it's very beautiful. If you think about it, it comes to us very naturally, and we don't really need to speak so much about even human values. What are human values? Yeah, if you think about it, it's what is our nature: to be loving, to be caring, to be kind, to be compassionate, isn't it? To care for others. If you think about it, our kids have it. We had it as kids, we still do. See, if there's one kid who's crying in the room, the others will also start crying. Why? Because that feeling that one is going through is felt by the other, isn't it? So similarly, these human values that we're talking about, they're contagious. If you're in the presence of a person who is very peaceful and very calm, how do you feel? Also the same. If you're in the presence of a bunch of people who are angry and fighting, use dirty language, how do you feel when you're with them? You're like, no, negative. You don't want to be around with them, isn't it? So, whatever emotions people are going through, they're also reflecting them around them. So, in fact, Gurudev Shri Ravi Shankar ji, our founder, says that communication happens not so much just through words as much as through your presence. So, these human values that we were talking about, they are our nature. To be compassionate is our nature. If you think about it, to be caring is your nature. To be compassionate means what? I'm looking beyond my perspective. I'm seeing where you're coming from. Yeah. To feel that. If you're talking about having a sense of caring, you have that for your loved ones, isn't it? So just enhancing that circle of who you care for, having that sense of belonging for everyone. When you do that, you start taking more responsibility. Yeah, we can create a better world if we just started to understand the others. Sadly, in today's world, what we are all doing is thinking only about I, me, myself. In fact, Gurudev Shri Ravi Shankar ji says that the best and the fastest way of going into depression is sitting and brooding and thinking only about I, me, myself. Fastest way of getting out of this is thinking about what can I do for you, helping others. Yeah. So just enhancing that circle of I, me, from being just me and my family to increasing the size. He says that the whole world is my family. Vasudeva Kutumbakam. No? If we really had that feeling, we would not be in wars with other countries. We would not be having conflicts with other people. That other comes because you don't have a sense of belonging. Yeah. So human values, very important. We've all learned about this. I don't need to really speak so much, but in today's age, because of the stress, we need to discuss that we need to maintain ethics, we need to have human values, because all of our thinking is clouded by the stress. It's like you're a beautiful diamond, but the diamond is covered with dust. So, cleaning this diamond and allowing your true nature to shine through, which is love, which is compassion, which is peace, which is this act of caring, sharing, all this is our nature. And that can shine through when we're able to get rid of stress. Yeah. So, I would like to end the session over here. If you have any questions to ask, then feel free to do that, because this is what I wanted to share with you all. Yeah, so we've had an experience of meditation, doing some breath work. These are your takeaways. Yeah, and at the same time, also wanted you to understand that stress is something that you can manage using the breath and doing a little bit of meditation. If you'd like to know more, please get in touch with us. The Art of Living programs teach breathing techniques that help to reduce the stress. Yeah. So almost instantaneously, we have breath work, where if you practice this for a few days, you're able to reduce the cortisol levels. So it is measured that it comes down by more than 56% with just a few weeks of practice. Similarly, anxiety levels also, your energy levels get increased. So I can continue speaking more, but I think we'll take a pause here, and I see a feedback link has been shared in the group. So for everyone, you can use that. Please share your feedback. If there's any questions, I'm still here for a few more minutes. If you have any questions, feel free to ask. Yes, anybody questions? Okay, Sarvanan, are you there? All right, so if there are no questions, then I can take leave from you. Let me know if there's anything else. Then I can stay back. Selvi, are you here?
Yes, ma'am. Thank you, ma'am, for your informative sessions to us. Thank you so much, ma'am.
Okay, yeah. So I'll take leave. Thank you so much. Bye.
Ma'am, thank you, ma'am.
Welcome. Thank you. Take care.
Thank you, ma'am.
Thank you.